Conclave, Decoding the Success of 5G's Grand Debut, Part A. So today we have with us Mr. Magnus Everbring, Apex CTO, Ericsson. Then we have Mr. Mike Fitton, VP and GM, Network Business Division, Programmable Solutions Group, Intel Corporation. Then we have Mr. Azhar Saeed, Global CTO, Telecom, Red Hat. Then we have Mr. Jayanta De, Executive President, 5G Business, HFCL. Next we have with us Mr. Ryan Tonelli, Chief Operating Officer, DriveNets. Then we have with us Dr. Badri Gumatham, Group CTO, STL. Then we have with us Mr. Harpinder Mitharu, Business Head of Product Marketing and Wired and Wireless Business, AMD. Then we have with us Mr. Girish Bhatia, Director, Sales Engineering, Sienna. And then we have our moderator, Mr. Nitin Shah, partner with KPMG. Sir, over to you.
Okay. Good morning, everyone. Am I audible? Well, great. Thank you. So I know it's a Sunday morning, considering the match we have in the evening. So I think it's difficult for all of us to attend this session. But I think thank you very much for everyone who is attending this session. And we will have a really interesting, impactful, and insightful session considering the esteemed panelists that we have today. Decoding the success of 5G's grand debut. I think this is a very interesting topic that the organizers have taken. Right. So just a year back, we have this eventful launch of 5G services in India, inaugurated by Prime Minister Modi in the same IMC 2022. And we all are very excited about the event, as we all consider this as quite an event in the communication services or in, telecom industry in India. But why is it so eventful? Why we all consider this as a milestone? We have been upgrading on telecom technologies for years. So we had 2G to 3G, 3G to 4G, and now it's 5G. So why is it so different that we consider 5G as a milestone event? I think the way I take it, I believe that while all these technology upgrades have provided or enhanced the service levels for the services provided to the end users, I think broadly the use cases were revolving around the user landscape across those services. 5G is giving us an opportunity to put up use cases across the business as well as community landscape. So that's where I think it's differentiate and why I think there's so much of excitement when we talk about 5G. 5G has opened a plethora of opportunities, driving digital enterprises, digital economy, as well as opening up opportunities for a new business and operating model supporting the entire startup ecosystem. 5G is also supporting some of the flagship programs of Government of India when you talk about Digital India, when you talk about Startup India, Atmanirbhar Bharat, and many more. As one of the estimates, 5G is supposed to accelerate the economic growth of the country, where 5G itself is going to contribute to roughly around 2% of India's GDP over the next few years. So that's a grand promise, and that's where I was excited when I looked at 5G's grand debut. I think this is really grand if there is a expectation to contribute to 2% of the GDP. But the other important aspect of the success for 5G, in my view, and I think that I'll also talk to my fellow panelists here, the technology is best when it brings people together. And that is the mantra I believe 5G is adopting. So the three key levers for the growth that 5G is committing is promising the industry collaboration and convergence. Right? So that's one of the levers that 5G is driving. The second is boosting the socio-economic growth by bringing the rural and the urban population together. And third, of course, the enhanced customer experience that it basically promises. So over the last 1 year, I think the pace at which we have deployed 5G technologies and services in India is commendable. With more than 3,000 or 300,000 sites, 5G sites, covering 700 plus districts. India has become nearly the second largest 5G infrastructure globally. The pace at which we are deploying 5G services and supported by some of the emerging technologies, when we talk about generative AI, when we talk about industrial IoT, when we talk about edge computing, I think it's basically driving the digital transformation for the country, which is taking us towards our next ambition to be the third largest global economy by 2030. So that's the promise that 5G is making to all of us. While there are a lot of promises on 5G, I come with a cybersecurity background, so I can't be not talking about cybersecurity. I do believe that it is also to a certain extent providing some unique challenges when it comes to cybersecurity. When we talk about all the other technologies, as I said, the use cases were largely around the user landscape. I think some of the use cases with 5G is promising, be it enhanced mobile broadband, be it URLLC services, when you talk about machine-to-machine communication. I think the risk and the threat landscape from cybersecurity is very, very different. And hence, that needs to be considered with a very different perspective altogether. The second aspect is the regulatory compliance. The recent that we all heard about the Data Privacy Act, the DPDPA Act, which has come in country, is also impacting, and when I say impact, I'm very cautious, impact both from positive as well as negative side, but there is an impact on some of the use cases of 5G when we talk about compliance to some of these acts. So with that, let me move to my esteemed panelists, and there are 4 key aspects which we will try to cover, and will be open to take input from the audience as well if there are specific areas that you want us to discuss further with the permission of my panelists. What is the potential of some of the leading use cases that we have seen globally, be it cloud computing, be it FWA, be it communication platform as a service, and many others. So what are those use cases which would be more prevailing in India? Impact of emerging technologies such as generative AI, and when I say impact, I think impact on both the sides. One is on the adoption of 5G as a services and how effectively we can operate or efficiently we can operate 5G services by leveraging some of those technologies, and also how we can enhance our 5G services using generative AI. So that's the second aspect. How is 5G is driving the digital transformation, boosting the Indian economy? And I think we have some sense over the last 1 year how it's helping out, so I think there's a merit in discussing that. And third, certainly there is a role that regulators need to play to basically assess how we can have an effective deployment of 5G, effective consumption of 5G services, and how should we get the industry collaboration further for the users of 5G. So with that, I will turn towards my colleague Ryan. Ryan has a fantastic experience in managing the large deployment of infrastructure. So what are some of the challenges, Ryan, that you see when you're looking at such a large critical infrastructure deployed at such a large scale and with such a fast pace? So what are those challenges that you can help and share with us?
Yeah, great question. Thank you for that. So first of all, thank you for having me. Secondly, I think we could probably have a panel just about this one topic itself. So I'll try and cover this at a pretty high level, but if any of you want to find me after the session, I'm happy to talk about it in more detail. I think there's a couple of assumptions we have to make before we dive into this. One of them is that 5G is going to drive an increase in the number of physical devices on the network. And by that, I don't just mean handsets. I mean physical IP-consuming devices that are sitting behind hotspots and FWA CPE. And I think we also have to assume that generally over time, the bandwidth consumption profile of all these devices is going to go up, right? So if we assume all these things are true, then I think there's 3 key areas we have to think about. The first one is edge computing. And I know we talk about edge computing all the time, and it's this, sort of amorphous concept that is different on an industry by industry basis. But let me give you an example of a place where I think this has a meaningful impact in the 5G world. So let's say that you as an operator want to go train an AI. Right? And you want to use, anonymized, tokenized data from your user base to be able to do that. Moving that data around, especially to a data center where you've got your training farm, has an implicit cost in your infrastructure, right? So being able to anonymize and tokenize and summarize that data closer to the edge has meaningful benefits in, the TTL of your, let's say, your backhaul and connectivity infrastructure. So that's one piece of it. The second is capacity, right? And this is one that has so many dimensions, it's almost incomprehensible. The first one is, if you're going to do edge computing, where do you put the compute and how much can you put there, right? Some of these cell sites, if that's where you're putting it, you may not have a ton of space and power to be able to accommodate growth. So understanding what your strategy is, when you're capacity constrained, what actions do you take? Do you deploy and then undeploy services based on what's relatively available? Thinking through your responses to those kinds of constraint scenarios, I think, is really critical before you dive into that end of the pool. The other is the physical network capacity itself, right? I could talk about RAN capacity. Actually, I couldn't because I'm not really a radio guy. I'm sure everyone else in this room could probably talk about RAN capacity planning better than I could. But then there's the backhaul piece, right? But we have to think more longitudinally about capacity. Don't just think about backhaul and RAN. Think about your edge, your aggregation layer. Think about your core. Think about your NNI edge, right, with all your peering and transit partners. 5G has the capability to more rapidly and more severely impact your overall capacity utilization profile more quickly than previous technologies, right? So being able to quickly respond to capacity demands in all those dimensions of your network are really, really, really important, right? How quickly can you add capacity with a peer? Do you know the answer to that question, right? You probably should, right? And if you've got hundreds of peers, being able to address each one of those needs independently is pretty critical. And then the last is the operations and maintenance piece of this. So, you assume you get this network deployed. It's large and complicated and has a ton of utilization on it, and you have to go do work. You have to add capacity or do upgrades or change devices. Your goal should be to, decrease the scope of the widget you need to touch to the smallest possible piece, right? Like, if you can disaggregate your hardware and your software, that means that you can touch those two pieces of your infrastructure independently. Without having to interact with a single supply chain, you can interact with 2 or 3 or 4 or 5. And then if you think about the compute side of things, a microservices approach, I think, is pretty critical, right? The thought of having to reimage a server every time you want to go deploy a new service in your edge computing infrastructure is sort of crazy, right? What you want to do is destroy a container and recreate it. So being able to address those compute needs in a microservices way, I think, is critical. And then last is be open. Locking yourself into proprietary technology just means that you're locking yourself into fewer options with regard to software and supply chain and all these different things that are relatively open and mature today, right? So use those technologies where they make sense for you, and I think you'll end up with a much more scalable and smooth deployment experience over time. Thank you.
Great, thanks, Ren. So before I move, I think I just wanted to cover another aspect. When you talk about data and you talk about data normalization, I think one of the other important aspect which is coming when you talk about the data is there's an amount of data that you capture, which is fine. You're looking for taking the services, you have to provide certain information, that's the data. And I'm primarily focusing on the personal data. But there's a huge amount of data which is getting generated, right? And that obviously is the new oil that we talk about, the data which is generated. And there's an amount of data which is getting inferred as well. So how do you manage that? And it obviously depends on the complexity of the use cases. But that's another important aspect, and it's again impacting the deployment of 5G, or more not as a technology, as a service, when you're talking about the use cases and keeping the cybersecurity aspect around that. So we'll cover that, but that's a very important aspect. Next, if I move to Magnus Ju, and I think from Ericsson, and Ericsson has been part of the India digital journey, and I'll be very honest, when I was preparing for this session, I realized that Ericsson is part of the telecom journey in India for almost over 120 years, with the first switch getting deployed in 1903. So that's fantastic, and you have seen the journey of India on the communication services platform, driving the economic growth that the sector has always supported. So how do you see India's journey on 5G and how it can further enhance its growth on 5G? I think, as I said, there's a lot of buzz around 5G, but how are we taking it up and how are we going to support the Indian economic growth as well as the industrial growth?
Thank you, and good morning, everyone. So first, I'd like to express my sincere admiration what has happened here in India over the last year since the previous Mobile World Congress is absolutely fantastic. Almost 340,000 base stations on the ground and operational. That is a stunning achievement. There are many things that can go wrong when you make a large deployment, right? But I think the operators here have really been showing great dedication and ensuring all major cities are covered. A number of factors come in place. I think regulation is one of them also. The spectrum auctions we had last year gave clarity, and then the improvements being done in right-of-way, etc. Now we have a fantastic base of 5G, and we're taking the next steps. And here's, of course, to leverage what's on there and to excel further. If you take a regulation, there more can be done. I'd be happy to see emissions being looked over, how much output power you can have at sites, which will drive performance if adjustments are done, as an example. But also, on the network side, this is a great first step, but more steps to come. 5G will live and thrive for a very, very long time, and it will evolve. If you look at what we have in terms of functionality, there are key important steps to take in the next years to come. 5G standalone, slicing, carrier aggregation, red cap, exposure, etc. are things that should be implemented in the network to be the base for the monetization that's now starting. And that will drive opportunities in new areas such as enterprise, industries, and the public sector. Everything will be connected. And it will be connected through differentiated services. This is a key thing here where regulation has to support the business opportunity for the good of consumers and the good of enterprises. So I think in the next years to come here, making sure that applications can leverage on the abilities in the 5G network with first-class performance. Just as a side comment, when I look at speed tests, typical speeds in major cities have jumped 15 to 20 times 4G with 5G compared to 4G. That opens up opportunities, right? So the performance has to be there, differentiation has to be there, and then being able to expose the values in the networks to app providers. That will unleash innovation. What we saw here at the inauguration with 100 test systems being open at universities is a fantastic base for future innovation. Take that opportunity and lead how industries can digitalize and be cutting the wires and then improve quality performance with 5G. Next few years is a fantastic opportunity.
So when you talk about innovations, and I think obviously technology and use cases are certainly needs to be innovated, do you also see that if we really want to explore the growth that 5G provides, there is a need to innovate more business and operating models? I was just reading, and I think communication platform as a service is one such model, because then you can provide this as a service to maybe the startup ecosystem to innovate some of the newer services. So are we seeing this kind of a growth? Magnus, as your role obviously globally is, are there such kind of a scenario you believe are being leveraged across geographies? And do you see this as a potential in India? Yeah.
So, I mean, the question was on indoor and other deployment.
So the question is more to basically understand possibility or need for innovating business models to leverage 5G.
Yeah. Oh, thank you. So I think on the business aspects here, one thing is technology, right? The second one is how do you put it place in the marketplace? How do we make it work? And here we have to innovate a lot more, we being the industry. I said before, differentiated services. Network slicing is a key functional support in the network. That we're now having our hands on, how to configure the networks, etc. The challenge now becomes how do we price it in the market? What's the value to consumer? What's the value to an enterprise? And this space needs to be crafted out now. Early movers will have an advantage. So I think India again is perfectly set here. Another area then is the exposure, and we just did a launch with Deutsche Telekom a month ago, where they're starting the first exposures and leveraging that on their enterprise portal. One example, applications can now ask through the aggregator platform, their enterprise portal powered by Vonage, they can ask the network, in which country is this device? Okay, so it's a very coarse level. But that is good information for credit card companies. Me being living in Singapore, if my credit card tries to make a transaction in Delhi and the app gets the answer that my device is in India, they have a higher correlation and they're more likely to grant that transaction. That information has not been tradable before for the mobile operators. Now it is.
Thank you. Thank you for this. So with that, if I move to you, Girish, and I think it's a logical movement to see what are the real benefits of 5G capabilities that the industry can leverage on, and specifically from the India perspective. There are a lot of promises which we see that 5G is going to bring the financial inclusion, social inclusion. So how do we leverage on some of those benefits that we see or capabilities that we see 5G is providing?
Thanks. Good morning. So if I go back to the inclusion piece, if you look at India market, it's split into two portions, the urban and rural divide. If you look at urban, we have more than 100% penetration of mobility of wireless internet. But that's not the case in the rural areas. We are still at 40%. And 5G brings a very good opportunity to actually, bridge this divide. Earlier challenges of infra that we still have, still exist. And I know government is working on a broadband project. But if you look at 5G, especially the FWA case, this will really help in bringing the divide much, much smaller, because it will be easier to roll out networks based on FWA. Because FWA has kind of two streams that I see. It's B2C and B2B. Now the B2C piece is where we will be able to kind of bridge the rural divide and bring more opportunities of farming, of education, of all other entrepreneurship that the Modi ji wants to do. So this is a very, very big opportunity for us to kind of bridge that divide. Now when you come to B2B, FWA is nothing but it's going to offer a lot of bandwidth. We heard from all the esteemed panelists, stacks of compute, stack of application. They're going to be there at a particular layer in the network. What we actually need to make this work is connectivity, and connectivity with enhanced capacity. So that's going to change a lot, and this is going to change the way networks are built actually. So in India, we use innovation to actually add more capacity, add more simplicity, add more services, but at a better cost than what we were doing earlier. So that's going to change. Because the way the services move in the network, that's going to change. And you will see a lot of innovations in optics, performance optimized optics, space optimized optics. They will come very close to the user, as Ryan was mentioning, the edge. So that's going to play a great role. And if you dwell deep, right, I think being open would really help, because the connectivity and the various platforms will actually give a chance for everybody to come together and kind of be open and work together. I think that's going to bring us a lot of use cases of 5G. And for the future ahead, because if you look at what we have done so far, right, it's not that we don't have any use cases. If you look at how insurance is done today currently, I don't know how many of you are aware of that use case, where a particular company is offering a service where if there is a mishap or an accident, you just take a video and photo and upload it to their servers. And your claim is actually approved within 1 or 2 hours. So that's a very fantastic new use case, which saves time, which gives you agility, and your work gets done faster. So these kind of things are going to come up very fast. We will get into generative AI, but again, it starts with inference. Yeah. With inference, we will be training our algos, we will go to generative AIs, and this will actually become better and better. So what I see is 5G is going to bring a lot of use cases, but we need to be ready with the infra. And also, I think we need to focus on closing the divide, where 5G, the easy rollout of FWA gives that opportunity for us.
Okay, great. Thank you, Girish. With that, I would also like to invite another panelist with us, Harpinder. Harpinder is the business head for product and marketing AMD. So, morning, Harpinder. Thank you. So, with that, if I can move to you, Jayanta, and I think you have been seeing this entire journey for last many years. So, how will 5G drive industrial transformation, and will it serve as a catalyst for driving digital transformation across sectors? So, when we talk about the sectoral convergence, we talk about, and I think what I've heard primarily use cases coming in more on the manufacturing, utilities, and another kind of agriculture is another area which is coming in. So, how 5G is providing those opportunities, leveraging maybe the industrial IoT, and maybe private 5G network, which we are talking about. If you can also elaborate a bit what exactly is that, that will really help. Thank you.
Thanks, Nitin. Good morning to all. So, 5G, particularly private 5G, is a great enabler for the digital transformation that is taking place across the industry verticals. Now, as per industry reports, globally, the 5G adoption is taking place in three main segments. First is manufacturing, second is transportation and logistics, and third is energy and mining. So let me start with manufacturing and in the context of India. So as most of you are aware, due to the current geopolitical scenario, all manufacturing companies globally are looking for diversification of their manufacturing supply chain. And most of the manufacturing companies today globally are essentially adopting a China plus one strategy. So India has the great opportunity to be a manufacturing hub for the whole world. So we are talking to a lot of manufacturing players in the country today, and we see a lot of interest in them to modernize their factories, to transform their factories into smart factories, and to build factories of the future. Now, the foundation building block of industrial IoT, or to implement Industry 4.0 use cases, is that you have to collect very accurate data in real time and from hundreds and thousands of devices, sensors, and machines in the whole manufacturing plant. So this calls for a network infrastructure that is highly reliable, is highly performant, is highly scalable, and has very low latency. And most of the manufacturing, and in fact all enterprises, also look for high security, which means that the data cannot leave the premises, whether it is a shop floor, a manufacturing plant, right? So if you look at all these stringent requirements of these mission critical applications, 5G is best suited to meet the requirements of these mission critical applications. So let me take a few examples based on the conversations we are having with some of our customers here in the country. So one of the leading automotive OEMs in the country today is looking at how 5G, and when I say 5G, I'm referring specifically to private 5G, how private 5G can help this particular customer of ours in improving the monthly production of vehicles. So today, as you know, in automotive vehicles, electronics and software is a significant component of a vehicle. So as a part of the production process, you need to flash the software into the vehicle. And the current network infrastructure that this particular customer of ours have, the software flashing is highly time consuming and is error prone. So this particular automotive OEM is looking at 5G to address this production bottleneck and to be able to increase his monthly production of vehicles. So this is one very good use case where 5G is helping an automotive OEM to increase and deliver additional vehicles per month. The second use case where we are seeing a lot of interest from our customers is how 5G can be used for autonomous mobile robots, for autonomous guided vehicles. Many of you who have visited a manufacturing plant or a shop floor must have seen that it is very dynamic. And for a wireless infrastructure, a manufacturing plant is very challenging because there is a lot of interference, there is a lot of metal objects, very high temperature due to furnaces, welding machines, and other heat generating manufacturing processes. So 5G is being used by these autonomous mobile robots and autonomous guided vehicles to provide reliable services. And more in the shop floor, these AMRs and AGVs are being used to automatically carry raw materials, semi-finished goods, components, and parts. So these are two, use cases we are seeing in the country when we are talking to a lot of our automotive customers and other manufacturing customers. Now, HFCL, we also have our own manufacturing plants. As you know, we manufacture optical fiber and optical fiber cable. So we are also implementing some of the industry 4.0 use cases in our own factory. So one of the use cases we are implementing is real-time dashboarding to help improve production yield. The second use case that we are implementing is how do we improve the quality process through real-time vision-based analytics so that during the production process itself, we are able to inspect and identify defective parts. So as we move along, what we definitely see in manufacturing, we are now moving from an era of mass production to an era of mass customization. So factories of the future will need to make quantum jump in productivity improvement, will have to be highly agile to be able to meet changing market requirements, and will require zero machine downtime. This means that there will be a huge adoption of some of the emerging technologies like digital twins, generative AI, and industrial metaverse. Now, all these technologies that I just referred to cannot be implemented unless you have a highly reliable, highly scalable network, and this can be delivered only by 5G. So I think I spent a bit of time on manufacturing, but 5G, and particularly 5G private, has equal relevance for other sectors, industrial sectors as well, whether it is mines, ports, right? So one of the challenges that ports and mines have, that their operations are spread over a huge area, sometimes covering, hundreds of acres. Now 5G helps to efficiently cover this wide area and to be able to, easily implement use cases like asset tracking, right? And to embed intelligence into the operations, right? Then when I look at energy and utilities are making use of the reliability of 5G to implement smart grid, to integrate new energy sources, green energy sources like wind farms and solar plants into the energy grid. So we see that 5G will act as an accelerator for the industrial transformation that across all industry segments.
Great. Really insightful, Jantar. Thank you for sharing that. And I think you brought an important point, what I could relate with what Girish you also mentioned, that infrastructure is the key. Depending on the use case, and particularly when you're talking about the private 5G or 5G private infrastructure is the key. The second point I think very interesting, and I'll quote somewhere, mass production to mass customization, which is also something maybe 5G provides an opportunity for. And considering infrastructure is so key, maybe I'll move to you and maybe seek your experience that how should back-end infrastructure, which we just heard is very critical for any kind of a 5G services deployment, this should be progress for effective deployment and operations of 5G, and how we can leverage some of the network slicing capabilities that 5G provides.
Great. Thanks for the question. Thanks to everybody for coming. It's like the worst session of the week. First session on the last day, so the fact that you've all showed up is great. I'm aware that there's a cricket game going on as well, so it's doubly good that you've all come to this instead. And the final note on that, I'm probably the token Englishman in the room here, so can I just ask everybody to go easy on me later on, please? So I'm going to start off, maybe be a little bit contentious, right? That I'm going to put a premise out there that as technologists, we're really bad at predicting what the killer application is going to be. I think we're really good at innovating, and particularly here you see the pace of innovation. But I think we're really bad at working out what that killer application is. And let me give you an example about that. Go back 30 years from now. It was December in 1992, and the first text message was sent. It was a young engineer sent a text message to their boss saying Happy Christmas, because his boss was at a Christmas party. That was the first use of a text message for non-network information, and SMS in GSM at the time was never really intended as a user application. Now, you fast forward just 5 years from that, we've gone from something that was never intended to be a user application to having the first mobile payment system, at least I'm aware of, where you could go to a Coca-Cola machine, you could send an SMS to that machine, and it would dispense a can of Coke for you. So think of that, 5 years from effectively a new service being established to it then having a entirely new business model. Magnus was talking earlier on about business models. And then you fast forward to where we are today, 20 billion text messages every day. 20 billion of something that was never intended as a user service. So that's what leads me to my premise that we're not very good at predicting that application. We didn't predict that one. But we are very good at adapting to it. And so the key point I want to stress here is the need for programmability, and the need for programmability end-to-end across hardware and software. Because if we're not going to be very good at predicting the application, then we need to be able to adapt to it. We need to be able to innovate. We need to have faster feature velocity in order to embrace those new areas. And you see that pace, see that speed of innovation occurring here, occurring at IMC, the difference from last year to this year, the deployments that are occurring, the private networks models that Jayanta was just talking about as well. It's incredibly exciting, but that's where we need a portfolio of solutions. We need end-to-end programmability, and we can't have a one-size-fits-all approach from the back-end infrastructure point of view. And let me just talk about a couple of examples about where that pace of change is required from a future-proofing point of view. Think for a moment about artificial intelligence and machine learning. So AI and ML is kind of uniquely both enables 5G and is enabled by 5G. If we look about 5G being able to extract data from the edge, about being able to utilize all of that data as well, there's a great opportunity for us there. And then 5G can also benefit from machine learning as well. If you think about, just to throw a few examples out there, you think about L2 scheduling or intelligent RIC, or if you think about, there's this classic amplifier digital predistortion problem that's a non-linear problem that we've always approximated to with linear mathematics. Well, now, machine learning is the best way of doing amplifier digital predistortion. So we have all of these ways that 5G can benefit from ML. But if we'd designed that, if we had a fixed hardware implementation that we developed a few years ago, we wouldn't have implemented transformer networks. We would have been inherently implementing something backwards looking rather than something forwards looking. And so that's where I come to my point about needing programmability to have future proofing, to have feature velocity. If you'd have implemented a neural network machine a couple of years ago, and if it was fixed, you wouldn't have been able to do a transformer network, and then you would be limited in what you could do with generative AI, for example. So as we look going forward, we have to make sure that we've got that feature velocity for all of the different applications. I also wanted to stress about where there's some really exciting things from future-proofing and programmability from a usage model perspective as well. So Joanna just gave some great examples about private network in industrial applications. But I was talking to a number of different delegates here about in transportation, and particularly in the train network. And you think about the train network, what a great example about network slicing that Magnus, to my right, just talked about as well. If you have a network slice, for a train network, I can both have a network slice that supports infotainment in the seat back, but I can also have a different network slice with higher quality of service that supports ultra-reliable, low-latency connectivity for safety-critical applications. And again, by that programmability built into the back-end infrastructure and built into the hardware that's provided, we uniquely enable that new kind of application as well. So with that, I just wanted to kind of tie it up at the end and particularly make that point again about the need for programmability. And if anyone disagrees with me about us not being any good at predicting applications, come and talk to me afterwards and I'll definitely invest in your startup idea. Thank you.
Great. Thank you, Mike. And now I'm really excited because you spoke about need for programmability. You spoke about AI, ML, and all of these things, which obviously brings me to my favorite topic, which is on cybersecurity. Because with so many things are happening, cybersecurity certainly becomes critical for this aspect. And this is like my perspective, and Azhar, I'll come to you to seek your opinion around that. What we have been doing on cybersecurity to date, securing the telecom networks, may not work so well when you're talking only for 5G. And it has to cover across the user landscape beyond the management and control landscape. So that's where I think I wanted to seek your opinion and your views. How, obviously it's important to secure 5G services, but what are the key aspects when you talk about evolving risk from cybersecurity perspective, specifically on 5G?
Sure. Thank you, Nitin. And thank you, everybody, for this opportunity. Before I get into the cybersecurity question very quickly, I'd like to double down on a few things I think the panelists made, because they're important to set the context with respect to security. One of the things that was talked about was scale. The other one that was talked about was reliability. The third one that was talked about was different use cases with respect to connectivity. 2 decades ago, we talked about quality of service on an internet service in a different way than we do today, because today we use Zoom. So connectivity is absolutely a necessary but not sufficient requirement to build new services. It's absolutely necessary. High-speed connectivity, build it as they come. I'm sure we all learned that particular paradigm. But what it also does now with high-speed connectivity is the amount of data that you're ingesting. I think you brought that point up earlier. With that kind of data ingestion that happens, and the observability parameters that we have actually put as part of that particular infrastructure, you're generating more and more. Users are generating, sensors are generating, infrastructure is generating data. And now you've got to look at that particular data and then run some sort of analytics. The questions naturally come up. What about security? How do I do data management? How do I do privacy? And you look at privacy concerns. You look at user data versus infrastructure data, separation, sovereignty. So these are all questions that immediately come up because now people are already building a lot of data lakes. People are already doing a lot of analytics. Sometimes people really don't care about the GDPR laws in Europe. It's very different. In the US, very different. India, I think, is just beginning to adopt a privacy policy with respect to data, right? So I think those things become absolutely necessary, especially in the context of infrastructure. Let me parse down a few things from an infrastructure and then go to the user perspective. From an infrastructure perspective, when you have observability and that kind of data, now you need to actually look for what is the posture of that particular infrastructure. How compliant is it with respect to regulation? How are you able to really satisfy all of the requirements? For that, you need to automate it. You need to probably use Gen AI techniques. You need to actually do what is called as hyper-automation, in my opinion, in terms of constantly checking, verifying, and providing information back to human-in-the-loop conversation with respect to automation to ensure that you're actually compliant. You're actually be able to prove yourselves that this actually works. And this is where it needs to be. Now, that is on the infrastructure context, but what about the user data, right? What about the privacy concerns in that particular context? Where, with respect to user data too, you cannot treat user data the same way you did before. I mean, I know that these days we are becoming increasingly more sensitive. Just simple changes with respect to GDPR allowed us to, have a button on the web page every time to say, do you accept cookies or you don't? I think we need to evolve that in many more ways. And that's actually, I'm going to double down on Mike's point here in terms of bringing better programmability. Better programmability ensures, you have the right kind of APIs. GSMA has actually taken up a project in Kamara in terms of how information sharing and user information sharing can happen with respect to this one API context. So I think those need to be further worked on. We need better frameworks around particularly data management and cybersecurity. I think we have to do more. We just can't simply say, yeah, let's do connectivity, let's worry about this right now, and everything else will automatically fall in place. Yes, maybe, but the pace at which we're changing, it's really, in India, you have a fantastic application, something called DigiLocker. I just learned about that, in this trip. It's an awesome piece of application. The big part is not just the application that stores your creds or credentials, whatever it is, whether it's your passport or your driver's license or something else, but it's universally accepted by the government and the enterprise as something that's secure, right? We don't have such a thing back home, where I live at least. I can scan it, I can put it on my phone, but that's not acceptable as an authentic verified document. I think these are some really innovative things that people have done here because of the digital inclusion, because of the connectivity, because of high-speed connectivity, and 5G will further improve and enhance that, and it is secure. So I think it can be done. India has shown that it can be done, and I'm sure we can actually extrapolate that and apply that in the enterprise context, in both in B2B and in B2C context.
Sure. Thank you, Ajay. And I think you did mention about the data part, data monetization part, and also securing that, particularly when it comes to the personal information. So for that, if I can just turn towards you, Dr. Badri, and seek your views in terms of what are the role that a regulator should be playing in terms of having an effective adoption of secured 5G services, and also some of the regulations, like we spoke about data privacy, will gonna have an impact both from positive as well as negative from the adoption perspective of 5G services. So your views on that?
Hello. So from just following, what the other speakers, we have actually created a lot of expectation on the success of what 5G means to us and so on and so on. I just want to take a step back and, when we talk about security and infrastructure, clearly we have built it on the backbone of a fiber optic network, and that continues to be the driving, let's say, enabler to get more and more towers built out, more backhaul networks built out, and then as we grow these services and these applications, whether it's in manufacturing or private 5G or things like the inclusion, which is, by the way, a fantastic application. I used it at a police check a few weeks ago to show my ID. It is amazing, these services. But I just want to make a small point that the way at least we have built that fiber infrastructure has always been vulnerable to damage, right? For example, there is, if you look at the statistics, here in India at least, the number of cuts per month per every 1,000 kilometers of cable assets that are in the ground or in the air, it's about 15 cuts per month. Whereas in other geographies, especially out west or maybe Japan, it's in the sub 1, it's in the 0.2 to 0.3. So we're quite, we don't have a shining example of physical network security on which we build this 5G in the future, right? Now, the point I'm trying to make is, if you look at recent events, Middle East, in places like that, Ukraine, it is very easy to disrupt that infrastructure. You don't need very sophisticated warfare or fighter jets and this and that to disable it. So one thing I would kind of ask from a regulatory standpoint is best practices in securing the fiber network so that you bring your outages down to zero. It is absolutely a mandate, I think. It can be done. It is a matter of unifying certain allocations of licenses, rights of way, enforcing the dig first, call first, call before you dig, these kinds of things. These are simple things to do on paper, but it does require a behavioral transformation, a business transformation for us to understand that this is something, if not done today, it could in the next 5, 10, I don't know, God forbid there is some kind of an event, But that is, let's say, a more, high-risk, scenario. But even today, the number of outages that one goes through, whether it's your private broadband at home, on which your 5G tower depends, or your data center connections, or even the physical attenuation that we experience in the network, right? If you speak to data center operators, everybody is concerned about the quality and health of this network, right? So that is something regulators should look at, I think, for the first point, right? And to your second point on the information security itself, I don't have much more to add than what people have spoken about. I mean, that's absolutely important for us, but there is a way forward. There is a path for open source. There's a path for programmability. There's a path for building, higher capacity, transmission equipment that can be, put together in so on and so forth. One way that, and we are working with some operators on this to improve the physical security of the network is, by the way, using AI. In a roundabout way, it is something you can sense when somebody is about to dig before they dig, and that is some property of optical fiber called fiber optic sensing, and that is something that our fiber monitoring. These kind of AI use cases show up in a roundabout way because we started investing very heavily into 4G and 5G and machine learning and AI, and then now we're coming back to it full circle and say, okay, look, we do need to, even if we can't secure the network, we need to monitor it, and we need to turn the repair time, mean time to repair, to nearly zero, so that these services are useful in terms of monetizing the use cases. If your network is out for 4 or 5 hours a day, I think in the long run, you'll lose money, right? It's not that complicated. These are the 2 points I would say from a regulatory standpoint to think about.
Sure. Thank you, Dr. Badri. I think on that one, there's an interesting thing which I observed. So I think, Mike, you mentioned a point on one size doesn't fit all. And when you talk about the 5G services and specifically on security, I can just take a clue from Azhar, you and Dr. Badri. I think, as I said, one size will not fit all when we talk about 5G network security as well. So I think when we are talking about 2G to 3G and to 4G, there was a baseline security framework which used to work to secure any communication network. But 5G security specifically needs to be aligned with the use case. I've been reading that there is a concept of connected hospitals which is coming in. Now, you just cannot afford the number of outages that you're talking about. You just can't afford those many outages when you're talking about the connected hospital and remote surgeries and all those kind of use cases. And specifically, the personal health information becomes another critical aspect when you talk about those. So, depending on the kind of use cases, I think that's where you have to balance. And obviously, automation is another fundamental key when you talk about cybersecurity in such of the emerging areas. So thank you very much for bringing that up. And with that, before I come to the audience, obviously, I want to come to you, Harbinder. So I think after all those discussions, what are the 3 initiatives that you want to propose to drive industry collaboration for driving an effective utilization of 5G capabilities to bring socio-economic growth for the country?
Thanks, Nathan. So you're asking for 3 key initiatives that can...
If you have more, I'm more than happy to have more.
Okay. So, first of all, given that I'm from AMD and we provide technology for end-to-end 5G as well as data centers plus GPU clusters for AI/ML. So I'm going to provide a perspective on socioeconomic growth with a different lens, right?
Sure.
So, and you called out 3 initiatives, right? So I would say these are not new initiatives, but I'll just reiterate some of the initiatives that we have just started, or these initiatives are in baby steps, I would say, right? The first one we talked a lot as we marched into 5G was hardware and software disaggregation, and all of you know about Open RAN Organization Alliance, right? So there was an intent to kind of create an ecosystem where radio from any vendor can interoperate with base station or baseband from any other vendor, right? From tier 1 OEMs in particular, right? So from that perspective, a lot of the technology providers enable the ecosystem, and today we have a thriving ecosystem that can provide radio. Essentially, when you talk of socioeconomic growth, it's very important for us to have a thriving supplier base as well. So today we have, say for example, if you go through the show floor, you'll find that there's a radio hanging from pretty much every booth. And if you come to AMD booth, you'll see that there's a wall which is full of radios that are made in India, right, from that perspective. Now the key thing is that now we have radio suppliers, and this is one of the challenge every tier 1 OEM has been facing, that they have to build one new radio every week and they simply cannot keep up, right? And we're just talking of FR1. When you bring it FR2, and then as we go into 6G, FR3 bands are being considered, right? And then you have terahertz. So you have so many different SKUs of radios that you need to support. So you need to have a very thriving ecosystem to support all those use cases. Now the problem there is that these radios today cannot interoperate very easily, right? So they're struggling to really get these radios deployed because there is a gap in terms of availability of DU that they can have access to or they can interoperate with. And if they get one, the performance is still deficient compared to something that is built by a single vendor, both baseband and radio. So I would say that there is room to make progress there. We have made some steps there in that direction. I think we have to continue to build on that and create an ecosystem that allows greater inclusivity, greater participation from the industry base to contribute radios for different use cases, for different verticals. We talked about private 5G. There's a different scenario where maybe operators cannot directly participate right away. They have different priorities to begin with, right? So that is number one. Then talking of number two is, again, it's very familiar to us. We've been talking about software and hardware disaggregation, and oftentimes we talk of vRAN, right? So, and this also was quite a big hype as we started on 5G journey. And so vRAN has happened. Maybe I would say 5% deployments are using vRAN, but it's not truly vRAN in the sense that it's still proprietary because it's fixed to a specific hardware, or the software stack that is coming is again coming from either tier 1 OEMs or provided by vendor, but then it's not quite open, right? So in order to really enable broader ecosystem to be more inclusive, to enable multiple vertical industries to participate, we have to provide this baseband framework that enables each vertical industry to participate more with more ease, right? If you talk about massive MIMO baseband, it's still. I was talking with one of the operators, and he says that truly it still is a rocket science because it's so difficult to really optimize that system. So not everybody can really come up with a solution that is end-to-end. So from that perspective, I would say that there is still room for us to make progress on hardware and software disaggregation to enable a framework that allows the baseband software to be open source, to be available as a Linux release, along with providing APIs so that even tier 1 OEMs can leverage the same software framework to create similar differentiation that they do with their purpose-built boxes, right? At the same time, we have now smaller, innovative companies. They have specific problems to solve for their vertical, or for urban or rural, for agriculture, or any other application. So they can come in and can leverage some of these frameworks that are available to add on their own APIs and solve their problems, right, using the same framework. So I think we need to make progress in this domain. Otherwise, I don't think so 6G will happen without that, because 6G is very much dependent on the third component, which is AI/ML, right? So because we called 5G to be cloud native, and now we are calling 6G to be AI/ML native. And I'll come to that in a minute. But the key thing is that if we have to enable 6G, we have to really have an open equipment approach, in the sense that you need to get access to the data sets. If you don't have access to the data sets, okay, you can still use reinforced learning-based AI/ML algorithms to really do something, but without having access to the data sets, it's going to be very difficult for you to tap into AI/ML from utilizing it within the infrastructure or managing the infrastructure, and then subsequently also leveraging this data set for creating new services, right? So I would say that AI/ML, why we need to pay attention to that, first thing is that there's significant amount of energy being spent in this area. Like you see new folks coming out of colleges, or the amount of research that is happening in AI/ML is quite significant across the board. So we have to tap into that. But if you step back and look at AI/ML, how it's done, basically any signal processing expert will see that essentially AI/ML is leveraging matrix manipulations, which is very much core to signal processing algorithms that we use in baseband, particularly in layer 1, right? So from that perspective, we see that there are some use cases like Mike also mentioned about that. Say, channel estimation is one very important area where significant improvement can be made. We certainly will continue to evolve the traditional algorithms as well, but we have to look at some alternatives that can provide good balance between system complexity and performance. And then, of course, scheduler, you mentioned about that, right? So these are the areas, where we have to enable these areas by, say, having open baseband implementation, which has got standardized APIs, either 3GPP or Open RAN Alliance creates this framework so that folks who are having expertise in this domain can come in and can provide improved channel estimation or equalization model that can be leveraged by any other vendor. Likewise for scheduler, because today if you have a deployment, you'll see that if the spectral utilization, even though theoretically is kind of spec to be, say, 100%, in reality, you'll be realizing only 1/5 or maybe 1/4 of the spectral utilization in a practical deployment. So there is significant room for us to make improvements there as well. So I would say that these are the three key areas. If we enable and have a rich ecosystem, thriving ecosystem, then certainly it can intercept multiple verticals, multiple areas to really bring in with the connectivity with 5G, as well as growing it to the next step, which is 6G.
Great. Quite a detailed, elaborated perspective, Harpinder. Thank you very much for sharing that. So with that, I have one question for all of you. But before I go to that, maybe I'll just turn to the audience and see if you have any questions for our panelists. We'll be happy to take that up now. Yeah, please, sir. Go ahead.
Thank you for your great knowledge that you shared the success of 5G deployment. My name is Dr. Lawal Bello from Nigerian Communications Commission, NCC, a body saddled to regulate the telecom sector in the country. There are some factors to consider in deploying 5G globally. Some key factors. One, the OEMs. Two, the telecoms regulatory body. The OEMs, we can consider them as a kind of key drivers in deployment of 5G. Now, one of the big challenges of 5G deployment nowadays is high cost of deploying the services. What OEMs are doing in terms of equipment subsidy, incentives to ensure that the telecoms operators access the equipment at a low cost so that the services will be more affordable to consumers. Because globally, if you look at from the time of launching of 5G to date, the subscription by 2023, end of 2023, will reach like 1.5 billion. And most of the subscribers are enterprise solutions. Therefore, what kind of subsidy, OEMs, or kind of incentives are they providing to telecoms operators to ensure that the services will be affordable to consumers? Thank you.
You want me to go first? I think very valid question that the new technology that we bring in should reach everybody and at a cost where everybody can afford and use it. So from a transport perspective, I think what you will see OEMs doing, and it's not only related to CNR, you'll see a lot of convergence. And that's going to be the norm where every OEM will come and tell you that this is where we'll reduce the cost of deploying the network. You must have already seen a lot of photonics, low-cost photonics, performance-optimized photonics, space-optimized photonics, and also the pluggables. So this is going to be the new era where you will find OEMs working together with SPs, delivering those low-cost solutions to create a lot of capacity much, much closer to the user. And this is something that we are also doing with our partners. The other thing, convergence. Of late or till now, you've seen multiple networks being built. That's also going to change. You'll find a single multi-layer network that can cater to all kinds of services. So that's going to be the next norm, which promises to reduce the cost almost by 40%. And it'll be a sustained model where you can actually select and choose what you want and what needs to be deployed. So these are the two things that transport OEMs will promise and deliver on putting low-cost networks.
Okay, so your question, if I paraphrase it quickly, is how can the mobile services be more affordable to consumers? And I think the challenge is great, and that's an ongoing race all the time. But I think if you look at both the infrastructure side on the mobile device side, when we go into 5G, we do absolutely the best technology we can do in the industry. And we do so because we know that at scale we can deliver the lowest cost per bit. Can show here, it's a ASIC. It's a dedicated chipset that Ericsson has made. We have it in our antennas. It's 9 billion gates, dedicated for its purpose of delivering a better service. That is a cutting edge what the industry can do in the world. Now, as an example, I think, look here in India, where 5G is launched now, and we're operating at ARPU levels of $2.50. It's just phenomenal. The race now is to drive the scale, so cost of devices goes down, and it will over some years. We've seen a good trend already from the start of 5G, and give it another few years, it will drop. And it will be the lowest production cost ever in the industry. Then we continue based on that, and we take the next technology step and continue that race year after year.
Yeah. Other.
Good. If I could just jump in very quickly and just echo that point. There's a relentless march on from a semiconductor point of view. My colleague on my side over here, from an AMD point of view, at Intel, we're driving it through Intel Foundry, through TSMC, through Samsung, going from lower and lower process nodes to support Magnus's ASIC that goes in their radio unit, and increasing the number of transistors that go in each time, which obviously can drive capacity, but is also driving down cost as the kind of key part of that. And the other reason I wanted to jump in as well is a huge part of that is also driving sustainability as well. As we go to the next process node, we've gone from measuring things in nanometers from a gate width to now, at least in Intel, we measure them in angstroms now. That's how fine a pitch we're doing. As we do that, we're driving down the power consumption, and that's the other area that we need to do. Not only we need to make it affordable, but we need to make it sustainable as well. Thank you.
Other, yeah.
Let me just take a step back to your question. You want to drive down costs for a new generation technology. that's coming? At a very high level, that's the question. How can you do that, and what are the OEMs doing? That was the original question. What are some of the levers of driving down costs from a consumer point of view, from a provider point of view? Some of the levers that drive down costs are architectures. What type of architectures do you choose? Are they closed or open? How do you allow competition to actually drive some of that cost down? And how do you create value within that particular framework? So if you take those levers, start pulling those levers. You have the power. As a provider, you have the power. You cannot you cannot just be captive to a vendor's, approach in that particular context. Above all, in this context, of course, go towards COTS hardware. Don't go towards dedicated hardware. If you can, do it. Of course, you have to worry about what he just said, is just driving cost per bit down, right? Can you pack more density into that particular piece of hardware and actually drive cost per bit down? Look at that, right? Go to adopt open source technologies. Create an ecosystem of environments with smaller, startups, companies, work with them. They're more hungry for business. So look at that, and as a matter of policy, you're actually, I heard that you're part of some, defining policy. As a matter of policy, define what you need in that particular context by providing those level of investments. Open source is a gigantic lever, don't ignore it. Of course, above all, and all this, adopt cloud. Those are some direct answers you're getting from me.
I just wanted to add one point.
Yeah, please.
In addition to the technology innovation that everybody referred to, the other is also, to make services affordable are the business innovations, right? So for example, shared infrastructure, not only the passive infrastructure, also the active infrastructure, can it be shared? That will drive down cost, right? Secondly, neutral host, right, is again another way to ensure that we bring down cost, right? So both technology innovation as well as business innovation is needed.
Absolutely. Great, thank you. Do we have, I think we can take one more question, if we have any. Great, so with that, thank you very much. I think we had a very fantastic discussion. I have my learnings to say that, yes, this is a great promise and quite a real promise that 5G is making. But one of the key things which I've learned today is that it requires a behavioral change for a successful consumption of 5G services, both as a consumer, as enterprises, and obviously as OEMs, to ensure that the cost is optimized as we move ahead. It also bringing us to the shared economy. So a lot of those business models and the operating models that we're talking about will get further enhanced with 5G if we obviously are looking at the shared economy. So there's a lot to go, but I think there's a lot which is happening and which has happened. So with that, we stay positive, and I think 5G will bring us to the promise that it makes. So thank you very much. Thank you very much for joining us, and thank you all. Thank you.
Hello everyone, good morning. We are going to start the session CTO Conclave, Decoding the Success of 5G Grand Debut, Part B. We have with us Mr. Rajesh Singh, EVP Technology, Radio Planning, Network Planning and Strategy, VI. Next, we have Mr. Shankara Narayanan Vishwanathan, Vice President and CTO Business Solution, TCS. Next, we have Bijoy Pankaj, EVP, Chief Technology and Strategy Officer, Mavenir. We have with us Kumar N. Sivarajan, CTO, Tejas Network. We have with us Michael Joseph, Senior Director, System Engineering, Fortinet. I would also like to invite our panel moderator, KG Purushothaman, Head Telecom, KPMG India. Over to you, Puru.
Good morning, everyone. It's still 11:30 now, and this is our second series on the CTO Conclave. This is the second session, trying to decode the success of 5G in the last 1 year. We all are aware that August 17th, 2022 was when the auctions happened, and the 5G auctions, 5G was actually rolled out from an India perspective. But the preparation for 5G, the ecosystem, the device ecosystem, and the entire rollout plan had already started with a lot of ecosystem partners and also existing OEMs and the telecom service providers for the last few years. The preparation had started, but the grand debut happened on August 2022. What we are trying to decode today is what has happened in the last 1 year. Last year, with the rollout of 5G, a lot of key developments have happened in the Indian context. We know that India has been the fastest, India has seen the fastest rollout of 5G from two perspectives. One is the fastest rollout of sites, more than 330,000 BTS sites have been rolled out. We have more than 100 million subscribers. But what we are going to unlock today is what has actually happened beyond these areas as well. We know that touching the end consumer is a very, very important perspective when it comes to 5G. But there are multiple other use cases of 5G beyond touching the end B2C customer as well. And we have a very esteemed panelists who have not only implemented 5G in the context of India, but also come with rich experience from their from the rollouts that have happened around the world. And what we are going to share today with with their insights is what actually needs to be done in the way forward as well. I'll probably start with Rajesh. Rajesh, from a VI perspective, there is, when it comes to technology advancements, it's not only the rollout of the network, it's about rollout of adjacent technologies, innovation in the way you are addressing customer challenges, customer experiences. Also, how you're working with the supplier and the partner ecosystem, that is also becoming important. Can you share your perspective of how has VI, and personally from your perspective, how has the last 1 year been since the 5G auctions? What initiatives have been taken by VI to roll out advanced technologies to prepare for 5G as well as the future?
Hi, Is my mic working? Yeah. Hi, thank you, Purushottam. I think it's very prominent questions in everybody's mind what is happening on 5G. There was a lot of, it's a hype cycle, what we call it. Technology hype happens, but if it doesn't deliver to consumer, the technology has no value much. So of course, once India has decided last year auction and then rollout, and as you explained already, there's a fastest rollout, but rollout is one side of the story. Infrastructure is being created, and India is leaping frog on that one. If you see the globally where people talking about 40-45% coverage, India is talking about 80-85% coverage. So that's a mammoth step has been taken. And same time, India is, as digitization and digital platform, digital transformation is happening, and digital infrastructure is very important. So 5G adding in this one, it's accelerating rather. Let me tell you what happens in the last 1 year. If you see the technology, and India was globally, if you see the speed index, we were 147th rank. We now leapfrog, I think 143, not 147. We leapfrog to now 47th rank. So we have 72 steps we jumped in. So, I mean, it will take years to move from one step to another step, but we just made a leapfrog and moved to now below 50, and of course, as things will move on, we'll further progress on that. One more aspect has to be seen, that the speed, the average speed, what user used to get, it was around 15, 16 Mbps, which is now reported around 300 orders. So it is 2,000% change.
Correct.
So no technology till now, or I tell you any product, if you bring auto industry, FMCG product, you buy a car, then you buy next car, the product change difference is only 10 to 15%. But here the product difference is 2x, 3x, and even sometimes 1000x. Either you talk about speed, user throughput, experience, latency, you just name it, and capacity, because India somehow, and rather than tell me Bharat, it needs a lot of capacities, because we have billion people to serve. And one more example I'll give you is the last time IMC we were there, and when Mr. Narendra Modi, Prime Minister inauguration was there, whole network guys, operators were on the hook. How to serve this 10,000 people gathering one place.
Right.
So there is war room, people on the field, back-end side, behind curtain, a lot of people are working. But still, I can tell you, last year we had the congestion in the networks, we faced the problem. But this time, because the 5G was there on the ground, we have not faced that problem. We have very, very successfully served the whole function. I think people can watch in who were there that time in Prime Minister inauguration. This time, whatever pictures, whatever things you were taking, all was they able to send it to next guy. And there was no congestion in the network. So that's what reflecting in consumers say, that what the experience is multifolding and changing. So that's where the adaptation, I think, success stories itself talks about. But it's not here because B2C is one thing, and 5G is not meant for only B2C.
That's right.
So in MBB, we talk enhanced MBB, and this will happen. But others, B2B and all other areas has to be unfold. And so operators are working with the entire ecosystem, because B2C is directly control of the operators, but somehow other aspects may not be directly controlled. It has to comes under partnership. So as a VIR, in fact, in all industry is working currently with the co-partnership with ecosystem, developing private enterprise networks, and other critical applications, especially Industry 4.0. So all things are happening, or healthcare, medical, education. If you see visit our booths, you will see all kind of use cases what we're displaying. And same time, we're seeing that a lot of traction is coming from the user sides.
Right.
For example, in this World Cup cricket, if you see that TV has moved to your palm. I'm saying everybody is watching. Nobody is watching on the TV. It's everybody watching on the. So streaming is, of course, going to be a big game changer, and it's there. But it's not only streaming. Streaming is users adopt this, and user will understand. And I said, in cricket, you're seeing similar. Maybe. I mean, there is a destruction. We're talking about TV industry. That's not right. Only the palm TV. What I talked about, the handset moving TV. Even the wireless home TV was through fixed lines. Now it's moving to wireless. And of course, India has the limitation of broadband connections, fixed broadband especially. That is a lot of discussion happening, and you see everybody was talking some air fiber, V fiber, and all fiber. So all getting converted to wireless, which is very easy to deliverable. So we're seeing the traction where now after hype, there's a little stagnation, and then now it's moving towards the traction where a lot of these use cases are getting developed, and I think consumer will enjoy that benefits.
Sure. We heard Rajesh, who comes from a telecom service provider perspective. And now I'm going to channelize my questions more towards first Shankar Narayan, who will give us a perspective first on the technology side and what advancement will happen. And then I'll move to what changes have happened from a network perspective. And that's where we'll bring in our friends from Avenir as well as Tejas. And then finally, we will also try to get a perspective from a security perspective from Fortinet around what kind of changes have happened from a security perspective. That's where we'll try to channelize, but the focus will be on decoding. So once we've set the base for what Rajesh has said, I'll request Mr. Shankar Narayan, from a technology perspective, 5G is the communication layer, but there are many other things around technology that is changing and that is making the use cases more successful, be it on the IoT side, be it on the rollout of the other device ecosystem. You have AI that is also have been brought in, and there are other ancillaries. Cloud is becoming prolific now. You work not only from an India perspective, but also you have a global perspective on what is happening on 5G and the use cases. How are some of these emerging technologies converging? And is there, and with 5G as a communication layer, are you seeing use cases that are actually becoming really successful first globally? And in the Indian context, what have you started observing?
Thank you, Purushottam. I think it's a very valid question. In my role in TCS, I have a very unique opportunity to help our customers understand and make technology real. Because there's a big difference between seeing a digital heart surgery remotely done on video to really doing it in a hospital. There's a big difference, okay? So making it real for our customers is the biggest challenge.
Right.
Automated robots, fully automated factories, automated warehouses are all the promises that 5G espouses in great detail. But far and in between, customers have struggled to embrace and make the transformation. The reason is multifold. So let me peel the layers of the onion. The way we always look at in TCS is 5G, incidentally, you should never put the cart in front of the horse. Okay, 5G is, to me, a metaphor. Don't use 5G as the baton to transform companies. Because customers will see the video, they will appreciate what you say in the video, but they understand the problems in the landscape. They understand the shop floors is riddled with wires. They understand that without people, you cannot have automated, you can't have AMRs because there's one step in the floor. You can't have an AMR robot running around. So there are significant logistic challenges which exist in our customers, which has to be understood and appreciated. So the way we look at 5G is, but all we said, 5G is a metaphor. I'll explain to you how we have to see the whole landscape. There are multiple technologies converging together which makes this biggest transformation happen. And to us, the next wave of digital transformation is in the operational technology space, is in the OT space. It is in the shop floor. It is in the warehouses. It is in the shipping yards and so on and so forth. First big transformation which is happening is IoT. IoT is happening in scale. The reason why IoT is happening in scale is compute cost is going down so rapidly. You can have smart chips, embedded chips, with sufficient embedded software in it, or you can deploy software at runtime. So IoT is becoming in scale, so which means you can have better vision cameras, for example, for digital quality management. You can have 4K cameras for drones and so on and so forth. The second big leverage is people say, I need instantaneous reaction and response to any decision which needs to be taken, which essentially means analytics, which essentially means AI. So AI, then immediately people say, AI, for responses to happen, it can't be sitting in your office. It has to be close to the point of incidence where the actual thing is happening. So AI needs to be deployed in the chip. AI needs to be deployed in the edge, and so on and so forth. Then comes the edge maturity. The whole notion of edge, there are multitude of edges happening. The whole notion of edge is so diversified. You have an edge in the shop premise, you have a near edge in the mobile in the Vodafone center, then you have your own cloud ecosystems and so on and so forth. then all of this ensures that you're able to process, respond fast, and so on and so forth. Then the new buzzword, generative AI. Everybody is fascinated by ChatGPT because the moment you ask for a menu, it is able to give you what you can do in Delhi and so on and so forth. All fascinating things with chatting, and it seems to be so intelligent. And then people are wondering, what does generative AI has to do with 5G and IoT? The biggest challenge which exists in any digital transformation is people forget the people aspect of it. It is either you have a portrait of Ranveer Singh or you have a portrait of Shankar Narayan. There is nothing in between. But most often than not, all the customers are in between. It is the gray which matters a lot. There is an interplay of people and systems together. You can't have 100% full automation. Even the most advanced automated car manufacturers are struggling right now because as made-to-order cars are coming in, you need people intervention in place. How do you create cyber-physical systems really operational? So it is about systems, automated systems, assisted by people. And there lies generative AI. Generative AI is not about intelligent chats. It is not about creating cool videos. Yes, it does that in a consumer context. In an enterprise context, it is able to augment a worker in a significantly different way. I'll give you a simple example. This is a shop floor which I visited last week in UK, one of the top car manufacturers, fully automated cars, etc., etc. What is the challenge in the shop floor is their FTT is 27%. First time through is 27% for a fully automated shop car flow. Why everything is automated? Then why it is only 27%? The answer is the devil is in the detail. Increasingly, people don't have the same cookie-cut car running around. Every car these days is made to order. I need the upholstery in a different way. I need this particular fitting. So the whole notion, the variety in the shop floor and the production line in a made-to-order manufacturing scenario is so complex. So when it comes to a worker in the shop floor, it very clearly highlights what is the rivet to take for that particular car, because that is automated. The DC machine, the rivet manufacturer conditions what is the power to be applied to the rivet so that the right power is applied. But what the person doesn't know is where to go and apply. As simple as that. So what he does is, he or she places in the most effective place possible and then pushes the car out. Because for them, if they stop, it is a 20,000 pound impact for every hour the production line stops. This is a classic case where if a generative AI ecosystem can assist the vendor, saying this particular car, this is the context of the car, this is the specific part, for this is the nuanced difference that needs to happen, do it this way. The whole shop floor transformation is a lot different. That is exactly where generative AI comes. Then the new technology, Web3. Web3 is not about creating cool games. It is not about seeing concerts in games. It is not that. It is about creating light applications for users. So if you are talking about an assisted laborer who's doing this rivet job, he or she needs an application through which they can consume this intelligence from generative AI, understand what is the right rivet to be placed for that particular task in play. And that application needs to be extremely light, and that is exactly where Web3 comes in. But all of these needs a very synchronized orchestration and guaranteed service delivery. And to me, there lies 5G. So if you look at the whole narrative of business transformation in a shop floor, it is 5G comes last. You don't need to go and sell to somebody. 5G is all about low latency, it is all about reliability, it is all about high bandwidth. No. The need will automatically be driven by how the transformation is going to happen. What are those needs of transformation? How should I drive that ultra reliability? And then naturally people will say, why not Ethernet cables have existed? In this particular shop floor, the reason is Ethernet cables do exist, but that is exactly where the DC current goes to for all the DC motors that are running. So Ethernet is not sufficient for them. Wi-Fi, there's a huge element of interference. So the 5G becomes a default connectivity fabric, which brings together multiple technologies like IoT at scale, cloud, edge at scale, analytics, various types of analytics, Web3 applications, bringing all of this together, orchestrating that, and hence I always call 5G as a metaphor. To me, we are at the tip of the iceberg. always statistics have shown that 5G has a huge promise in the enterprise space. All data right now points to a huge adoption at the consumer side. The adoption is yet to happen at the enterprise side. The reason being, people want to understand how to make this work in their shop floor. While they have seen presentations, while they have seen beautiful, cool videos, making it real at the shop floor is where the rubber hits the road. And that is exactly where the biggest impact we can make for enterprises at large.
Thank you, Shankaran. I think one theme I might say is common, between what you have suggested versus some of our previous panelists is around the use case around automotive and manufacturing. From my own personal experience on working on some of these use cases, and we did also a survey across sectors, manufacturing is one of smart factories, manufacturing is one of the biggest use cases apart from logistics and others. But one theme that is clearly underlying is transformation. How can you show the transformation ROI? And if I may ask a follow-on question to you, you mentioned about the use case in UK. In the Indian context, where are these conversations leading? Are you discussing some of the challenges that we face? You did allude to one particular challenge, which is to say, is there an alternative with Ethernet and Wi-Fi being there? Is there a use case? So one example that I have in the example of manufacturing is one of the biggest challenges that we are not able to yet demonstrate is 5G able to solve a challenge around precision manufacturing. Precision manufacturing is one of the biggest challenges, and that relates to even other sectors like healthcare, where you require a high level of precision. Theoretically, it is possible to solve it. Have we actually done it? Are you having these conversations in the Indian context as well?
I think very good question. I think the Indian context, the biggest difference between the Indian context and abroad is all our customers abroad are riddled with legacy. They have huge element of legacy platforms which has existed in the past, and their ability to unwind and reimagine the new landscape is lot more capital intensive. In Indian context, perhaps that is not there. But at the same time, in the Indian context, we have to understand that it is worker-centric industry. Here you cannot go and pitch a fully automated factory shop floor to a customer in India. It doesn't make sense, because they feel the capital investment far degrades in value to having 10 employees running the shop floor on their own. So here it is all about how can I empower the employee a lot faster and make that task a lot more simpler. So essentially here it is all about personalized augmentation. That's the word I use. So when I talk about augmentation, so we need to calibrate and provide our positioning to our customers a lot differently in India. In India, it is about personalized augmentation. How can I ensure that every employee or every skilled laborer in India is able to perform at a quality which is far different. So here the problem is different. Here it is, say for example, if I have 1,000 employees, if an attrition rate of 5% degrades the overall quality of outcome from a shop floor, their challenges are different. Their challenge is how do I keep the training abreast? How do I keep each of the employee abreast with what is the security processes, etc. So here the narrative that we are pitching is there are areas where you don't go for full shop floor automation. Here we go for part automation where we are able to take the difficult tasks out of the employee and made automated. Second level of automation is make the employee assisted in terms of analytics and AI to help employees do their job faster. Here it is all about speed. Faster and more effective, in the sense that even if it is a junior employee, their ability to come to speed a lot faster, because literally it tells, take this particular bolt, take this particular rivet, go to this particular socket, just do this twist to 3/4 of an angle. That is all you have to do. So it's basically you are automating, and only thing is you are using the hands and feet of the skilled laborers there. So our positioning shift has to calibrate to a slightly different level to help them understand and appreciate how we can increase the throughput and so on and so forth. So, but the promise is once you articulate that this is how I can assist the laborer, these are the points of intervention where automation can really make an impact, then the next question, obvious question comes is, can you just stitch this together?
Right.
And then immediately 5G becomes the vehicle to do that.
So in the Indian context, it's all about how do you make the digital workforce more relevant
and effectiveness of skilled labor. It is not about removing laborers and then making it automated because nobody trusts systems.
Sure. Thank you, Shankar. I'll just come to you in a bit. After understanding the impact of technology, I'll like to move to the our friends who roll out the actual network. Kumar, if I could come to you first and then to Vijay. Kumar, from your perspective, you are rolling out India's indigenous network, great success and great success stories as well. What are you seeing? I mean, you've heard that in the context of India, it has to be very customized, very specific. You also heard that consumer use cases of 5G is a no-brainer, but industry use cases will take some time. Are you seeing very specific challenges when it comes to the Indian context? What has been your experience so far after the auctions have happened?
So yes, we've been beneficiaries of the government's policy to promote Indian technology. And we're now happy to be part of the Tata Group also in that capacity.
Do you want to go?
I need to keep it closer. Yeah,
better.
I think
Thank
I can hear the echo here. Yeah. So I think from the government's perspective, this indigenous technology was to ensure that we become an exporter, like of the technology, like we're doing with manufacturing of phones and so on. So we're just not consumers, but we also are providers of technology worldwide. Right. And this is consistent with the encouragement of manufacturing of phones and so on, right? The second aspect was, to some sense, have control over the technology for security reasons to make sure it's there. So I think it's both an economic and sort of a security initiative, a security imperative that's causing this. In terms of rolling out, we are rolling out a 4G network which will upgrade to 5G. And the thrust here is also to roll out in areas where there's no connectivity, right? So now with whatever the digital stack of India, everybody needs to have access to the internet, to even for daily transactions, for banking, whatever, right? So we cannot GPay. We've seen people, for even 5 rupees you pay through online. So there will be a section of the people who will be left out simply because of lack of connectivity, right? India tried through BharatNet to try and get fiber to the villages, but I think that's a very difficult task. It did succeed, but then you get to sort of one point in the village, right? And then you really need connectivity at your home. So, and also the urban people have mobile. So I think the real need of the hour is to get a mobile signal, 4G, into every home, not just some kind of broadband in the village. So I think with that realization, the government is deploying 4G saturation. So the idea is to ensure that no person is left without 4G access, right? That is today. And tomorrow that will be 5G access. So and I think rolling out in those terrains have its own challenges of power, backhaul, and what you take for granted, fiber-based backhaul and all you cannot do. Power is a challenge, just access to continuous power. So I think those challenges will have to be overcome to ensure everybody has access to a 4G signal. Coming to 5G, so I mean, just to think about it, you may have heard of Rural Electrification Corporation. So that was set up probably 50, 60 years ago to ensure every village had electricity. And they completed the task maybe 1 or 2 years ago. The government declared every village has electricity. But look how fast every village or every portion would have 4G network. That's probably in 5 years or something compared to 50 years, right? So things are moving at the internet pace. Coming to 5G, I think you didn't ask the question, but I'll answer it anyway. I think 5G has succeeded simply because we are so starved for bandwidth. Okay, so it's not that any new application has actually been enabled. It is just that we need to stream the IPL and the World Cup and everything else, and everybody needs to do it. And there was so little spectrum. So as soon as new spectrum became available, the operators lapped it up. the 100 million people who had 5G phones moved to the new spectrum when they could, and that made the experience better for everybody else.
Correct.
So really, even now, the success of 5G in India has been driven only by the requirement for a lot of video streaming, entertainment of every kind. None of the other initiatives have taken off. Whether it's URLLC or machine type communication has not taken off, because I think they're sort of ahead of the time, because we had to set some goals for 5G after 4G, and we set these goals, but we couldn't realize them. So hopefully by 6G, we will have enough time to really figure out what is that requires URLLC. Gaming seems to do well, even real-time gaming, without this URLLC. Maybe it is operating robotic machinery. We still are in the process of figuring it out. Okay, so that's what it is. I don't know if I answered everything.
No, thank you, Kumar. I think you covered one very important aspect, which I thought I should have also asked you, 4G saturation, and thanks, because while the focus is around 5G rollouts, it's very important that rural areas and others which may not be immediately tapped are also covered. Thank you for covering that. Vijay, if I could go to you, congratulations first of all on your new contract that you've won with a service provider. What has been your experience on rolling out an Open RAN stack or an open stack from an Indian perspective? Can you share first a global perspective on how things are working out on the rollout, and in the Indian context with brownfield implementations happening, where are you seeing the niche spot which you are trying to tap, and any specific learnings that you have from an Indian context?
So how much time do I have?
You can 5 minutes.
Okay, because I could speak for a long time or go pretty short. So thank you, first of all, happy to be back here. I'd say from a global perspective, as we see 5G rollouts happening, there's a transformation underway from an operator perspective, because monetization has been the biggest challenge for operators. You spend so much more in rolling out 5G, but ultimately, if it doesn't lead to more revenues to the operators, we as vendors don't succeed, and the operators don't succeed either. And it's been the OTT guys in 4G, at least, that's monetized on the network capitalization that's happened. So I see a bigger focus on the network transformation, be it 5G on enterprise side or for consumer side, on ways to monetize. And monetization covers two aspects. Either you bring down the cost of your network, you generate new services. And RAN, of course, is the biggest part of the operator spend. You spend globally, it's around 40 billion a year. And in that perspective, Open RAN has the possibility to remove the vendor lock, bring in innovation, create new players in this ecosystem. And obviously in India, through local manufacturing and through the ecosystem that's being set up through Aspire and other initiatives, you'll see a lot more innovative companies and new prospects happen in the space, which is earlier locked by two traditional vendors. So Open RAN, of course, it's still in early stages. We see it's definitely not a 6G thing, because as some vendors have been positioning, it's happening in 5G. We're seeing large-scale greenfield deployments of Open RAN right now, but expect to see more brownfield Open RAN deployments in 2024 and 2025. The other aspects we covered earlier, of course, from a technology perspective, across different sectors, whether you're targeting healthcare, government, agriculture, we saw in pretty much all the operator booths here, the vision of how we would monetize 5G. And in that regard, moving to a standalone network, which Jio is the only operator at this stage in India who's done it, and globally as well, the adoption of standalone networks has been slower. But we see the push to standalone as a big way of monetizing, especially you look at network slicing, be it in the consumer context for AR, VR kind of enhanced experience, or for enterprise use cases, that being a big aspect to it. We talked about IoT. There's also a big push now for RedCap, the reduced capability in 5G, to get to, and Airtel, for example, just had an announcement on that with MediaTek. So we see that as a global initiative. Another key one on monetization has been networks as a service initiative. So the whole open gateway and API pitch to the network. I was just in Telefonica last week. They are some of the leaders in how we would evolve this towards a metaverse-ready network in the future. So the whole cloudification aspect to it is reducing the cost, be it Open RAN deployment or using the public cloud for disaster recovery kind of scenarios. But ultimately, I think for the operators to be successful and vendors to be successful, you have to monetize the network. And we see a heavy emphasis on that. With India, initial rollouts have been accelerated. You talk about Jio rolling out a cell site every 10 seconds, or Airtel having launched XYZ services. But ultimately, I also see that a part of it is being slowed down deliberately because the initial pitch on monetization 5G has not happened.
Right.
And hopefully it's not a 5G advanced or a 6G use case thing. And especially globally, what I see is FW has been a good use case where monetization has happened in 5G. Network slicing is still in early stages. IoT, of course, it's got we've been talking about billions of IoT devices even in 4G days. But from a monetization aspect, I think it's still early. And there are several areas of technology that can help towards this monetization aspect. You talked about Gen AI in that context. I'd say from a network perspective, the availability of data and the cloudification, be it a software-defined network, and the fact that you have access to a lot of streaming data and analytics that goes along with it, be it on the OT side or IT side, the tools which the hyperscalers bring through partnership with vendors or partnership directly with the operators, those can play a key role in how the network gets analyzed and monitored better, which ultimately leads to lower OpEx. Right. And when you have more dollars or more cash in the operator spend, that eventually will get spent in other areas of the network, be it on API pitch or other avenues. So in summary, I would say we're in early stages. There's a lot of new technologies out there, but work on it with caution because you wouldn't want to just deploy technology for the sake of deploying technology. We saw that in cloudification virtualization with OpenStack. I mean, all the vendors were on the CAS providers pushed it, be it Red Hat, VMware, and others. But ultimately, what happened when it came to the operator network, even within a same server, operators deploying OpenStack just wouldn't scale or wouldn't share the server between vendors. So whatever promise that was there with scaling and utilization of resources more efficiently did not happen ultimately because of the way the operators run the network. And we don't want that same thing to happen in this new cloudification to containerization using the public cloud or private cloud premises. Ultimately, you still have these vertical stacks, which are all being managed by the individual OSS systems that each vendor brings to the table, and you're not able to utilize the common OSS tooling, which can run on the RAN and core and transport network. You've not reduced the cost of managing a network. And that's where we believe the cloudification and moving to common OSS tooling and cloud tooling would leverage get to lower OpEx costs for the operator.
So Bijay, if I could ask you a follow-on question. So in the Indian context, are you spending a lot of time also educating and working with operators on some of these joint initiatives? Because in the Indian context, interoperability is something that is still being experimented. And are you facing some practical, if I not use the word challenges, but practical situations where you are working with the network teams of all the operators, and what is your experience around that?
Maybe I'll try to break it into what we're seeing on the RAN side versus the core. On the core side, we've been in that market since 2005. We've got pretty good experience in terms of integrating into incumbent networks, replacing the likes of pretty much all the vendors who play in the core space, be it on IMS or packet core. And that's pretty well standardized. And even though you have a lot of products in IMS, where you have a lot of interfaces in the packet core space, 3GPP has well defined those interfaces. So replacement of vendors, be it the Chinese vendors on regions bordering China, which it's pretty much happening in all the operator networks in India, where we have played there, we've not run into challenges, be it integrating into a third-party HSS or SDM, or even for that matter, mixing TAS and CSCF kind of domain. On the packet core side, I'd say in the last 4 to 5 years, we've been playing in that space with vendor replacements globally as well. And there, again, the advantage is that it's fully standardized, it's open interfaces. We've not had the issue with an HSS on the EPC side or an MME interfacing with another node that we bring to the table. So that challenge, there's been some amount of it, I'd say. The bigger aspect there has been on the SGI services, DPI, how the charging happens. Right. Because especially in the Indian market where you have these different circles, and how you build for different circles, and each sector being monopolized by one particular vendor, and you're replacing that full stack. The billing aspect has been a bigger challenge on the packet core side. RAN is a totally different story because it's always been a locked network. And with the Open RAN, now you have the benefit of being able to mix the radio and the baseband. But at least the first version of it in the Indian market, they're viewing it purely from a TCO perspective, saying, today I get a full stack offering from Ericsson and Nokia at X price. You meet that price, whatever other benefit that you bring down the road in terms of removing vendor lock, innovating with the radio intelligent control and all that, I'll reap those benefits down the road. But to me, right now, it's a cost play.
Right.
And if your TCO does not match what I have, then I'm not going to accept your solution. That's the first challenge that we had to get over. And luckily, we are past that stage since we're working with a few operators here. The second piece has been the lockout on how networks have been deployed in the past. Even though 3GPP has defined interfaces like X2 between the base stations, practically nobody has opened that interface between an Ericsson and a Nokia system.
Correct.
So even globally, when we look at how circles are deployed, each state is allocated to a vendor. And if you have to do a capacity expansion within a state, you always go to the same vendor because you have no other provision. And what we're finding out is when we started the work here, because X2 was an open, we would and NSA was the path, right? Outside of Geo, both Airtel and Rajesh can speak to BIL plans. NSA has been the path, and there you have the X2 challenge.
Right.
And if you don't have an open X2, what will happen is a new player coming in will have to bring an overlay band on the RAN side. So the good thing is with the push from tier 1 operators globally, now we're able to do X2. So that challenge has been addressed. Another problem that we see down the road, which is not yet addressed and which we're actively working in the Open RAN standards, is around carrier aggregation. So today, if you look at capacity augmentation on 4G or 5G, the best way to bring additional capacity is CA. And this is not something that's standardized in 3GPP or in O-RAN today. And if you look at vendor solutions, there are custom ways in which you could do carrier aggregation across within 4G and within 5G, but it's a vendor-specific solution. That I see as a challenge going forward. And the other pieces in terms of backend integration to OSS systems and all that, I think that we can solve.
Yeah.
But from a spec perspective, I'd like to see the areas of CA, X2 being opened up. And of course, the whole chipset ecosystem has to evolve. As I alluded to earlier, this is a cost play.
Yeah.
And volume is the biggest part to general purpose chips. And when you're playing with Intel that provides Sapphire Rapids Nice Lake chips, which are not just for the telco sector, they play in manufacturing, they play in many different verticals. And they don't price it separately for different verticals. So unless you hit the price point on a volume perspective, you're not going to hit the TCOs that can address the Indian market. And that I see is another challenge that needs to get addressed.
Sure. Thank you, Joy. This lays a good foundation. Michael, if I could come to you. We covered an operator's perspective. We covered the use cases and the emerging technologies. We also covered, a very important aspect about 5G being cloud native, programmable. But with 5G, there's a lot of data. You come with a unique vantage point that you actually have to face a lot of other challenges, first on the data side, second on the security side, both on hardware and software. What has been your experience from the discussions that you're having both in India and outside on what has been your version of the success of 5G, or for that matter, the rollout of the networks for the readiness of 5G in the Indian context?
So to answer your question, so if I were to touch upon this 5G aspect, one of the things from what we had been working with is more from a private 5G angle.
Yeah.
Right? We had been engaging with various system integrators, various telcos, and even the 5G use cases, as Shankaran was talking about, it predominantly goes back to the manufacturing, it goes back to the transportation industry, it goes back to the logistics.
Right.
Now, one of the classic use cases which I can correlate very well, when I was working with a service provider 3 decades back, we had rolled out EDI for the central excise to the ports, etc. And I remember the challenge was that when a ship comes, the data needs to go to customs, it has to go to the port crest. Now EDI was the first place where they were talking about a standard as to how this. But then the connectivity part at that time, that was a bigger challenge. I still remember people used to come to our office with a floppy to share the data because the connectivity was a challenge kind of. Now, rewinding from there or moving fast forwarding that, now we have a project what we have successfully rolled out in globally, where we had been partnering with a private 5G, specifically from a port, and what we had been trying to address is when a ship is kind of nearing a port or whatever, how quickly that data can be transferred to the various agencies so that they start processing that data. And if you look at the cost effectiveness, right, when a ship docks at a port, your clock starts, right? How efficiently you are able to unload and load and go. A lot of times, even from an Indian perspective, that paperwork is a big hindrance. The cranes do the job, logistics can be done, but in terms of what can be processed from a paperwork, that becomes a hindrance.
Right.
And that is a successful project what we have worked on. And similarly, there has been a lot of discussions which has happened purely from a OT manufacturing perspective as to how private 5G system integrators are working with various automobile or certain other manufacturing industries as to how it will help them in that scenario. Because again, that sensors giving you early data points, warnings, efficiency levels, because as again, what we are talking about from a OT or a manufacturing, that kind of perspective, like what Shankar was referring about, any downtimes or any hindrance in the production, it's directly translated into dollars and it can multiply. Right? So what we had been working with all these providers is in terms of when this connectivity is going, we start looking at how to secure the connectivity part of it. Then, as you said, there is huge volume of data, how to protect the data. Now that can be a cloud, that can be a data center, hybrid environment, how to protect the edge, where the data is getting access, etc. Then also look at the visibility in terms of who is accessing data or what are the bad actors who is trying to do whatever. And that is where a lot of this AI ML also can come into play. Right? We have huge volume of events coming from various points. Right? It could be a tab, it could be a sensor, it could be a server, it could be networking equipment.
Sure.
So this huge volumes of events coming, it's not practically possible for a human to go through it and analyze and see is there something going wrong, or to correlate to see is there somebody trying to actually circumvent the existing security measures or whatever controls what has been put in. Now that is where AI will be able to train and maybe give predictive warnings in advance so that you are better equipped to proactively look at what is happening in the network, give visibility, and then look at as to how you will be able to better equipped to handle this kind of a situation once it arises to the remediation factor.
So, but Michael, if I were to just focus on the network hardening part or even encryption standards that are being rolled out from an India perspective, now the new data privacy laws which are very specific to India, are there any specific learnings that you might have so far? I know the rules have yet to come out, but any discussions that you're doing very specific on the security and the privacy aspect?
Yeah, so we are working with various agencies, especially from a government digital initiative perspective, whether it is state governments, whether it is PSUs, whether it is at the central government level. Like whatever the security, whatever the digital transformation journey what they are getting into, we are working with that agencies to give them in terms of what we have seen globally when somebody was rolling out, what are the framework, and why these pieces are required. Because when you look at an automation scenario, I'm sure this colonial pipeline we have seen even in India now, right? There have been outages to critical infrastructure, right? Somebody trying to compromise or has already compromised, etc. So once we automate this, it's also very, very important that we protect that.
Right.
Now, what are the measures to be put starting from endpoint to application protection, network protection to all these various angles to be looked at? What could be the framework to look at? like we were talking about, even from security, in the olden days, different vendors never used to talk to each other, they never used to share threat intelligence, etc. From there, we are evolving where it's becoming open standards. There are standards being created. Again, API is the thumb rule using which everybody integrates. Now, we are helping the agencies to look at a scenario where you can create an ecosystem where you are not dependent on a vendor, where the system can scale up. Because
Open data architecture.
The data volumes or the transactions, what we are talking about from an India perspective, once the 5Gs and the connectivity becomes better in a rural environment, etc. It's going to be very huge, maybe which rest of the world may not have sized it or not anticipated.
Sure.
So whenever the systems are getting created, it's very, very important that the structure what they are creating is a highly scalable one. As per the business requirement, the bandwidth requirement, the user requirements, it can scale up. And 5G also, based on the kind of throughputs what you can get, the backend infrastructure also needs to scale up.
Sure. So, Michael, before I open it up to audience, Rajesh, if I can come to you and ask you one very important question. We covered, everyone to your left are your service providers. And you work in tandem with them to make things happen for the customers. From a vendor and partnership ecosystem, what kind of what kind of opportunities you're seeing, what kind of challenges that you're seeing, or any advice that you want to provide for the partner ecosystem to customize their solutions for you in the Indian context? Now, I know there are device manufacturers that are coming, the software companies, there are solutions that are being brought in, but are you seeing any change in the way partnership and vendor ecosystem is evolving, and any recommendations that you might want? And then I'll try to open it up to the audience.
Sure. I think it's a very important question when the technology, transforming. So if you see the other, before 5G, generally the services were limited to voice and data. Very limited to services we used to talk. But when we today were talking, if you see this, all panelists also talking about IoT, Industry 4.0, enterprise. So it's 5G is encompassing everything. So here the technology partner role has changed. They're not simply a box supplier, they're also part of the solution supplier.
Right.
So that's a big thing, change is happening, and I think we are associated with all our partners. And recently, if you see this phenomena has happened like air fiber, what you also earlier referred, the FWA is also came as a big driver from the technology partners, not by the only device guys or others. It's a technology partners driving. And Vijay is here, and we're also talking about, of course, the same time, Orion is a lot of discussion happening on the Orion side. So that is where the TCO front, of course, TCO is one of the requirements. It's not the only TCO is the requirement. This is where this technology exploration point of view, where the 5G is giving a lot of things, but it's now every application is a different service.
Right.
So where RIC and all is coming, XApp, RApp, so it's a partnership which is a lot of APIs getting opened. So it's an entire ecosystem has to work now. It's not simple box supply, just give the voice and data. It's just beyond that. And even this IMC also saying a lot of startups, both startup, we are saying everybody is doing, people connected. We are on our booth, we have a lot of startup companies who is showing the AR, VR gaming. So it's both OEM as well as device partner. Of course, device side, more on the, I think in Indian markets, more of price size has to be a little worked on. OEM has to not only supply the boxes, they have to give the right solution, and they have to jointly work that consumer easily adopt it, and it goes as a solution, not only simply as a box supplier. So that's what I say.
Fantastic. So we heard from Rajesh the fact that consumer demand and where 5G is most effectively expected to get the largest attraction. We heard from Shankar about how some of the use cases beyond B2C are going to become relevant, and the challenges that he has been seeing and opportunities that he's seeing in servicing the transformational levers that organizations have. We heard Kumar speak about the importance of 4G saturation, and also the fact that 5G as a demand itself is very, the capacity augmentation that is happening is creating a demand by itself. We heard Bijay speak about how Open RAN is going to transform not only greenfield but also brownfield operations and what challenges he faces. We heard Michael speak about some of the security challenges. He also spoke about open data architecture and how that can be leveraged. But before I ask them the next round of questions or a concluding set of questions, is there anything that the audience would like to ask them so that we can, we can have a few questions, yes. I think why don't you introduce yourself and please ask the question.
Hello, yes. So my question is on smart manufacturing, and I know the service industry is a very important element in making 5G in a real thing inside the smart manufacturing, and that's what I think Shankar Narayan you actually referred to. So like in the hinterland of IT Delhi, let's say Gurgaon, there are a lot of factories, and we have a program called Flexible Smart Manufacturing under some of our professors who are trying to bring all the flexibility into the manufacturing things. We see a lot of challenges, especially if there are legacy equipments which have to talk with current machines. So how do you think a service integrator, or maybe taking from your experience, should address this problem? Is it as investment into a platform that can enable projects, or into the projects as turnkey? So what is your opinion going forward as a roadmap for TCS? Thanks.
The moment I saw you in the audience, I knew I was going to get a bummer question. So thanks for that. You lived up to your reputation. So I think it is always a chicken and egg story, okay? Where do you invest first? I was earlier the CTO for TCS facing into all the telecom service providers. And one of the biggest questions they always ask me is, Shanky, I've got the fancy new tool called 5G. Everybody likes my presentation, but nobody's buying. The enterprise side, nobody's buying. So one of the things is somebody has to step in to create this as platform capabilities. At the end of the day, I think Bijay made a very important statement about TCO. So when you look at individual use cases within a shop floor, the business case doesn't stack up at all. The business case just doesn't stack up. Because it will be good, but you will at best be improving productivity by 10%, which is not commensurate to the capital investment cost that they need to go through, or the rip and replace transformation cost that they need to go through. Second is, nobody has an appetite to spend 2.5 years transformation journey on a business platform which will completely transform, unless otherwise they have I'm talking about the complete mid-tier of the manufacturing sector. I'm not talking about the top tier, because it's easy to give an example of the top tier who has the appetite to do big spends. The biggest chunk in India is the mid-tier, where the normal curve lies. Where we see an opportunity is platform players either being funded through a telecom service provider or a systems integrator, providing the integrating glue between what the manufacturing customers want to achieve with technology versus what the technology providers in-depth do provide. I think there is a huge opportunity play, and that is where I feel a lot of platform plays might start to come, emergent platform plays might start to happen in India, where you will provide platform as a service capability to enable smart manufacturing to jumpstart, with both sides of the ecosystem, the provider side of the ecosystem and the servicing side being integral part of the ecosystem. Because nobody has the money to build the platform within their enterprise. The concept is naive if you say that there's a platform within the shop floor. It doesn't work that way.
So is there anything like standards, or that you're looking at, or you have to invest in standards?
There is a need to invest in standards, predominantly because all the technology pieces are evolving very fast in silos. Okay, you have an individual use case being shown in the AI. You have an individual standards being developed with devices and manufactured. You have all the machines evolving in robotic machines evolving in a completely different pace. So there is no integral glue which brings up. So one, if you say, will there be a standards body which will emerge? The answer is no. But there has to be some element of abstraction layer to be built in, and that lies the foundational glue for such transformation that you're talking about.
We can add to that. Add one point to that. So you asked about smart manufacturing, but if we draw a parallel to the automobile sector, there's a 5G AA association. So it's not a standards body, but at least they're looking at how do you implement use cases in the automobile sector in a way that is transparent to connectivity and services. Because the whole challenge with smart manufacturing is that first is the device ecosystem has to mature. So you can't just take a legacy 40-year-old system that's out there, even a last 10-year system, and convert it to 5G, because a lot of them use proprietary protocols. So that device ecosystem has to get addressed first. Connectivity is just a small part of it, and the skill set to actually provide that end-to-end stack is missing in many cases, because it's only the manufacturing guys who really know how these systems work and how they're integrating the back-end IT systems, because this whole service transformation does not happen with just connectivity change. The entire stack has to work across, and that's where system integrators, beyond just service providers, and this is where we see the challenge even with, take one of the largest global operators, Verizon. Their big push has been on private networks, and they've set up their business group with the positioning that they will generate X number of revenues, and even in the last 2 quarters when the earnings results came out, they kept pushing it out because they said this has been so challenging even just to provide connectivity. Because even to provide connectivity between a small to medium enterprise, the variables are so huge that you cannot have a cookie cutter solution. And then when you look at any large enterprise transformation that has to happen, whether it's smart manufacturing or agriculture or across any vertical, you have to bring in a system integrator, because those are the guys who know how the IT systems work with the OT systems, how the connectivity layers work. And system integrators are stepping up in 5G to be the likes of TCS or IBM and Infosys and others in the Indian market. They are the ones who could eventually bring this to fruition, because the skill set is lacking, and the people who have knowledge across these different horizontal layers to build this end-to-end vertical stack transformation is very few. And they're very sector specific. So you have to bridge this team together. You have Accenture and even the consulting firms, McKinsey and others, who are playing a role in this transformation. So I think this is something that will take a few years to play out. There'll be certain verticals that would have some initial blueprints implemented. The platform concept is good, but to realize the concept, it takes a lot of work. And you'll have to start with some blueprints, and those blueprints can eventually extend from one vertical to another.
Yeah, you have a question there.
Hi, I'm Vikram from COI. So it's not a technology question. I know it's a CTO roundtable, but it's addressed to Shankar and Kumar. Both you folks, I don't know if there's the equivalent of a CTO in BSNL. I haven't heard of one, but possibly there is, right? So here's my question. The question is, you will roll out a 4G network, segue to 5G. All your subscribers are 2G subscribers. There are 200 million of them, right? With each technology, this becomes more expensive. What's the discussion you all are having with the government or internally to move these 2G guys onto a 4G network, which you'll roll out pretty soon? You know, you mentioned the Bharat Saturation Project. It's okay, the fiber will reach there, but the consumption and service delivery is on this. Yes. And this has to be made available. So what's the discussion around that?
So I'm not discussing anything about moving 2G to 4G, but once we roll out 4G saturation in all this, I think there are, I think the government and the BSNL have done their homework. There are many 4G users there with 4G phones will be able to access the network. The problem is there are so few of them that it's not viable for any service provider, including yours, to set up networks there. So I think the impetus is needed to set up these things in spite of economic unviability. I think that's what they're doing, so that The 4G users there will be able to access the 4G network if they have a smartphone rather than being stuck with 3G or 2G in spite of having smartphones. By the way, there are a lot of smartphones. There's a huge used phone market in the rural areas where it is a thriving market. And once this network is set up, that will actually create an impetus for people to go out and buy even a second-hand phone. So I think it's a chicken and egg problem. Okay, so you can say they're using 2G because that's all they have access to. But if they have access to 4G, they will quickly move to 4G with a cheap smartphone, and there are plenty of them available.
No, Kumar, there are people, 2G is in urban areas as well.
Yeah.
It's not in villages. Rural areas, you know, whoever can afford a smartphone has afforded one. But the fact is that 200 million guys cannot afford that. And the device is expensive.
Yeah.
So, you know, having discussions with USO or DOT, there is a need for focus to get these guys onto 4G. And
Yes.
So far I see there's a gap. So maybe I was wondering if you guys are having a conversation.
No, I'm not having a conversation, but I think market forces will drive that. I think we are very good as a country to adopt to market forces. So if people see the value in 4G and they have access to 4G, then they will find ways and means to get a 4G phone. Okay? So look at it. Every person who's selling you anything is a QR code and you can pay him 5 rupees. You know, how did that happen? Simply because that's an economic necessity for them to do business. So once they have access to 4G, phones will be there. We'll find a way. We are a jugaad country.
I can add something? Yeah, Rajesh wants to add. Just one second.
Vikram, I will little give you the add-on on this. Because yes, this is a challenge for us as well, 4G since long and we're not converting. But you're absolutely right. Somebody has to intervene this part. And recently we're seeing some intervention from the government. As you're saying, maybe these people talking to government, but we've seen in Rajasthan's circle recently, the IGVSI scheme they call Indira Gandhi Sanchar Yojana. And they offer roughly 2.5 million women's free phone. Government has intervened. There's a DBT direct bank transfer of 8,000 rupees to buy a smartphone. And they are we bidded that, we win the solution RFP, and we supplied 2.5 million SIM card to these guys. So there's a joint venture plan with operator and government who serves 2.5 million women last month just to serve this 2G to 4G. So this kind of a scheme will work, I feel, slowly in many markets. Otherwise, yes, you're absolutely right. They're not going to buy 8,000 rupees phone. Of course, I got only 75 rupees per SIM per month.
I think, not a flippant answer, but I think 2024 with all the elections coming in, I am hoping there will be a lot of 4G phones available for everybody.
Yeah, I think there's one more question and then we'll conclude.
Yeah, our question is to Bijoy. This is Ramesh from HCL Tech. How do you see Open RAN deployments going across the world? There's very few Open RAN specific deployments. Though there is 5G deployments which are very vendor driven, but Open RAN hasn't been hitting off, and number of players, because of the disaggregated architecture that was supposed to come, and the whole plug and play concept of getting the vendors change for each component, that's not witnessed either, right? So how do you see Open RAN and going forward? Is it having any movement, or is it going to become a 5.5G, or will it become a 6G only kind of thing for Open RAN architecture?
So just stepping back a minute, right? So when we started with Open RAN around 6 to 7 years ago, the whole concept was that you would have a plethora of companies pop up doing radios. And the initial intent was that you'll have a lot of Chinese companies build radios, and we would just build the software side from Avenue perspective. We would leverage the ecosystem of Chinese vendors building out these radios, and maybe Ericsson, Nokia, and others would start opening up their radios. What did not happen, what we did not envision at that time from 2017 on, was that the US kind of locked out the Chinese players for the majority of the world, because once that motion came about, we had to go build specific radios. So the biggest challenge outside of all the other areas of interoperability, all of those can be addressed. But if you don't have Open RAN compliant radios, and there's no Open RAN, you don't put a software in, because there are variants of this which Ericsson and others talk about, Cloud RAN or vRAN, which is just virtualizing the software side of it, the baseband side of it. But you're still not opening up the radio to a baseband. So we see that as the #1 challenge in terms of getting Open RAN to scale. The good thing is now we have players like Fujitsu, NEC, KMW, Mavenir, ourselves, we have our own radios, and we have interoperated with around 17 different radio players. We see that we need to see that ecosystem succeed. And there's a big push from vendors, from operators, and the governments as well to kind of open up that interface. And recently, 3 weeks ago, we had Ericsson just came out saying the new versions of the Open RAN specs, at least a massive MIMO, they're going to make it Open RAN compliant. We have to wait and see because that's 2025 before you're going to see that spec closed on the massive MIMO side. So once that happens, and you'll see more of those radios come about. The other big part has been this evolution to the RIC, the radio intelligent control, and you'll see a lot of players come in doing XNR apps. The challenge there has been, if you look at Ericsson's positioning, they say, we're not going to open up the E2 interface to a near real-time RIC. We'll do the non-real-time RIC, which is more like an evolution of the SON as it exists in the network today. Our view is that eventually this would get opened up. You'll see more players. If you, as an example, take Cohere. It's a standalone company who's just investing in spectral efficiency, and take operators who are spending, be it on 2G, 4G, or 5G, the cost per bit per megahertz that you have to spend. And if any app that comes in, which gives you 2x multiplier in your spectral efficiency, and if it comes from a third party, which is innovation, and this whole 100 testbed, 100 use cases that was just launched 2 days ago in India, if we have one of those players come up with an app which can interface into an Open RAN system, improve the spectral efficiency by 2x, or improve the coverage where you don't have to build these number of cell sites, obviously a vendor like Ericsson and Nokia just building their own in-house solution is not going to be able to compete with that ecosystem. It will take time for the ecosystem to mature. But we see that as the path forward, where you're able to mix and match radios, which doesn't happen today, and innovation driven through XNR apps as a true path which will accelerate Open RAN into the broader ecosystem. Now, specifically, where is the market today? In terms of how many trials that are happening, all that, there's this ORPC-based map which is being posted on LinkedIn and many other places. If you go to Mavenir blogs, you could see that as well, in terms of number of operators who are actually experimenting with Open RAN and trialing out. But in terms of true scale, Dish, many people would discount Dish saying it's a greenfield network, but Dish today has around 15,000 sites live, 10,000 of it is in Mavenir, and they're the first ones to actually do an iPhone certification, iPhone 15 certification with Warner. And when Apple does a certification of Warner or any network KPIs, they don't differentiate between an Open RAN network and non-Open RAN network. It's the same set of KPIs for the UE. And we were the first ones to pass that in Dish. So from a standalone network maturity, we are there. Where we don't have the proof points yet is in brownfield networks in large scale. And this is where the likes of Deutsche Telekom, there's a couple of tier ones in the US who's not public yet. Deutsche Telekom is public, Vodafone UK, who's deploying it in urban markets in UK. You'll have Orange with the Pick Your project. In other Asian markets as well, there are a few players with whom we're playing. And of course, in the Indian market, it's not public. A lot of people don't talk about it. But from a timing perspective, as I alluded to earlier, we'll see small number of sites go live, which are in brownfield this year. You'll see larger scale deployments happen in 2024. And you'll see a much bigger rollout happen in 2025, because it's not just about going and deploying Open RAN for the sake of deploying Open RAN. There needs to be an investment cycle that goes along with it. If you look at operators, take Airtel, who's already launched a bunch of sites. They've launched close to 90,000 sites today. And if Open RAN was ready and they were comfortable, they would have launched with Open RAN from day one. There's a maturity cycle which KPIs need to be met, and we are in that process right now. We're pretty comfortable where we are. But that maturity, that investment cycle in India happened late. In other areas of the world, that investment cycle can come either in terms of an existing vendor having to be ripped and replaced because they're a Chinese player, or the operators acquiring new spectrum. And if you don't have an entry point in which you could bring in a new player, because there's a cost involved in integrating and bringing in a new player, this won't happen. So you have to look at the solution maturity, the ecosystem maturity, as well as the investment cycles at which the operator can bring in a new player, which can be either 5G transition or a spectrum addition in 5G transition, or in future with 5.5G. At least globally, what we're seeing is the tier 1 operators who started with 5G, they're looking at either FWA kind of use cases to bring in private networks, rural areas first, or new spectrum acquisitions that they do to bring in a new player.
Can I do just one follow-up?
We are running out of time, but
Just
if you
one,
can,
yeah. Sorry, Vijay. This E2 and O1 that you talked about, the interfaces to get apps above, right? X apps and R apps. But do you see, the large number of them defined, right? Because see, the data and the way in which the control of the RAN can be done has to be synonymous or uniform across all the vendors. So even if that happens, E2 and O1 APIs are fully defined, the specific RAN vendors optimizations below, they don't give the same homogeneous data for the apps to work, right? So if I do an X app with a model, does it work for an Ericsson network vis-a-vis a Nokia network? Should I do separate modeling for each one of the vendors, or do you see homogeneous model working across vendors? So there are those kind of challenges as well, right?
So from an E2 perspective, it's still in the early stages. Right now, there's just a few of those metrics that are defined. And you have to look at this from either an API concept or an SDK concept. So the idea is that you could have data which is normalized and sent to the app provider, which is the approach that Mavneer has taken. We have a network intelligence as service platform which normalizes the data. That way, any third-party XApp or RApp provider that comes in doesn't have to know the nuances of what that data means. The alternate approach is you just implement the spec as is and you rely on the XApp or app vendor, which is the approach that some of the other vendors are taking. Our push in the standards has been normalize the data with the platform layer in the RIC, which then allows more applicability to the long tail of developers of X and R apps.
Okay, thank you. Thank you. I think, we have completely run out of time, but if I were to just take one word answer of what do our panelists see as the road for transformation for 5G or communication technologies for India in the next 1 year. One word that defines it. If I could start with you, Michael, just one word, and other than what Vikram has recommended, and other than the platform.
Yes, so for me, the 5G is going to be a major catalyst for the WAN transformation.
One word. Sorry. WAN transformation. Kumar.
Ubiquitous connectivity by network sharing.
Excellent. Bijoy.
It's more than one word, by the way.
Yeah.
I'll just say open. Keep the network open.
Open. Shankar.
It is integrated.
Excellent. Rajesh.
Monetization.
Monetization. Thank you. With that, I'll thank my fellow panelists. And you know what, my experience across the 6 IMCs that I have been part of, the best answers that we get is when things are not scripted. So thanks to the audience to ask those questions and get the best out of our panelists. Thank you.
Good afternoon, everyone. I hope everyone had a healthy lunch break. It's always a little bit of a challenge to be in the first session post-lunch. So I hope we can do enough justice, to keep the energies awake in the entire session hall here. My name is Alekh Tiwari. I am a partner with KPMG Consulting Practice. The session that we are going to talk about today is focused around edge computing. To give you a background on what we are going to cover in the session, data center is one of the space which is very hot space for India. We are seeing a lot of growth momentum. Arguably, India would be in a place where we can almost call it like the data center decade, right, for the country. In terms of growth numbers, if I talk about the data center space in India, we are looking at a growth of more than 15% year on year over the last several years. India today has, just to give you a little bit perspective on numbers, India today will have close to 500 megawatt approximately capacity of data centers, and it's expected to touch more than 1.5 gigawatt in the next 5 years. If you look at the plan of the various players who are setting up capacities, and if we count their individual plans, it will probably cross 2 gigawatt. The only country which comes in the range of these numbers is US. US today, the capacity would be around 2.5 gigawatts, right? So India is already around 1/5 or 1/4 of the capacity. And if you look at the growth plan, in 5-6 years, it will probably be very close to catching up with US. Even today, another metric, if you look at megawatt per capita consumption, right, it's very, very low for India. So there is a huge opportunity for data center growth. It's also driven a lot because of the factors like 5G, right, factors like IoT, Industry 4.0 booming up, factors like adoption of cloud, right, more and more people looking at adopting cloud, which will need a lot of infrastructure, IT infrastructure to support cloud. So that's where data center journey is a growth journey. It's close to a $5 billion market today, and it's expected to again double in the next 3 to 4 years in India. One of the important sub-growth areas in data center is edge computing, right? What we call as edge computing. That's essentially a smaller setup of data center, but driving slightly different needs or slightly different specific use cases. And we are going to talk about edge and beyond. So that's the theme today of the panel. I'm joined in by eminent panelists here from different organizations, thought leaders from in different and specialists in different domains within data center, edge, cloud computing, infra, AI, those cases. So we'll start, and maybe as we go through, we will also have specific questions to the panelists, and that is the time I'll request the panelists to also introduce themselves. We will have around 30 to 40 minutes panel discussion, and after that we'll open it up for Q&A to everybody present in the hall. So to begin with, let's try to understand what is edge, right? We have all heard about data center, we have heard about the hyperscalers, and now there is this term edge. And within edge also there are more terms like far edge, near edge, deep edge. So I'll request Piyush, if you may want to just talk about what is edge computing really mean, what are the various versions of edge, and what is there to what is basically driving the demand for edge computing in the country.
Hi, I hope I'm audible. Yeah. So good afternoon, everyone. I'm Piyush Sinha from Red Hat. So I take care of technical sales for India and South Asia for a vertical called Telco, Media and Entertainment in Red Hat. So yeah, so what is edge? Just before this panel, I was talking to one of the panelists, right? So he was telling me that 5 years ago also we were talking about edge, and people, and I think today also when I talk about edge, I will be talking exactly the same thing. So what has changed in the edge, right? So first of all, we all need to understand what is edge. Edge, when we say, it's a place in the network which is close to the user. When I say user, it can be a device, it can be an enterprise, it can be a human being, it can be a computer. Whoever uses consumes the service. So that's the user. Anything which is closer to the user, which is the access layer, is what edge is. Now, we need to understand what was the whole purpose of edge computing, right? So any technology, when it is required, so there are only two reasons why technology is required. It addresses two things. Number one, that there is a business problem for which you don't have a proper solution, right? And that's why you want evolution in the technology or technology enhancements to solve that business problem. I'll come to what that business problem was. The number two is that there are opportunities which you want to capitalize upon, the business opportunities. But since you don't have the right kind of technology, you are not able to capitalize on those opportunities. So what was the pain point and what was the opportunity which edge claims to address? The pain point was that as the IP and data evolution happened, we started producing
manufacturing, automation. All of these have been around for a while. It just didn't happen, but manufacturing globally, we had the most 43% reduction in workforce during COVID, right? And we had all the supply chain issues. So they also accelerated a lot of automation. So if you look at these segments, what is pulling this suddenly was like almost a post-COVID phenomenon. I just wanted to add that lens. So as we build out the networks, you also have to be very careful on use cases, points of consumption, industry verticals where this is happening, right? So there's a massive pull, which wasn't there in the past, right? So it's like, hey, almost, I'm impressed with UPI, digitization, transaction, but that also was forced through a motion of COVID, right? So I think it's and this has been nice to have pre-COVID, but post-COVID it's become a must-have.
Thanks, Munib. Thanks for chiming in. So going further, a little bit further on the use cases, because I think that's an important point from a business perspective, right? What is the relevance of edge and what could possibly be picked up? What could be the killer use cases? In fact, yesterday we had 2 or 3 sessions here only at the IMC, which was just focused around 5G killer use cases. We always talk about killer use cases. So we have Ludwig joining in us as well, and Ludwig, you're coming in from Singapore, right? And Ludwig leads a multi-million-dollar business at Ericsson. So Ludwig, if you could throw us some light, and must be working on 5G with various telcos and looking at 5G adoption across various countries, India being one of them, and maybe other countries as well. How do you see 5G in India being a little different than others? Is India in the same pace? Because India has, in many places, especially in telco, has actually leapfrogged the technology as compared to many other countries. But the 5G is just launched a few months back. So as compared to other countries, do you see any specific killer use cases, right? Or other use cases, telco-driven use cases or 5G-driven use cases, which largely utilize more of edge, right? Which you think could be relevant, maybe relevant for India or may not be relevant, but do you see any global emergence of good use cases around 5G leveraging edge?
Yeah, thanks. Thanks for the question, and really exciting to be here in India, where I think it's really happening. So I'm based out of Singapore. I run our cloud division for Asia Pacific, South Asia Pacific. I've got a relatively large team, so we're 3,000 people, and the majority is here in India. And I can tell you, we've been super busy building 5G networks here in India for our customers. We're really honored to be deploying them here in India with our customers and our partners. It's absolutely amazing what India has done, this 1 year. In 11 months, gone from 0 5G users to 100 million, and we're going to add another 30 million this year alone. No other country has the speed. And why do I think this is exciting? So I don't know about you, but when I was a kid, I always wanted to be born 50 years in the future. I'm born in the 70s, black and white TVs, The phone was connected to the wall. It didn't even have buttons, you know. It had this, you know, dial thing, right? Now, we live in a 5G era. India has just put rovers on the moon, on the backside of the moon. Elon Musk is going to send people to Mars by 2030. We've got self-driving cars that are starting to, to come. And we've got these pretty cool devices which we can connect anywhere in the world. So pretty much is happening now. But talking about use case, something that really hasn't happened is utilizing the full potential of what these networks can deliver. But if you look at the speed that India has, you look at the partnership that we see with universities, it's going to blossom like crazy. And why do I say that? Because the networks that are being built now are more than a communications network. You know, before you could do SMS and voice and you could do data, but the networks that are built today are really platforms of innovation. They're platforms of innovation. So why do I say that? Because now with the networks today, you can slice them and you can dice them into different type of characteristics for the use case that's needed. And why is that important? And I'll use one example of a use case, which actually Airtel has been working at. You did a partnership with Apollo Hospitals and launched use cases for healthcare, which is quite important. So when you slice a network, and you need edge for that, because you're going to do compute in the edge. And why do you slice it? Because you want to ensure that you have a secure channel. You know, nothing happens with that. You want low latency, and you can't give low latency to everyone. You know, there's not enough spectrum for that. So you can give it to a few. So one use case is a use case that we've been working in the healthcare industry for some time. It's called a haptic glove. Do you know what that is? Haptic glove. Anyone tried? Haptic is like, it buzzes, but it actually doesn't move. So in ambulances, we're putting these haptic gloves. Because if something happens to you, you want to get to the hospital pretty quick. But it's not always so easy to get there quick because there's traffic. And it takes time to get there. So what you want to make sure is that once you reach the hospital, all of the investigation is done so they can do what they need to do on you. But it's hard to put doctors in every ambulance. It's impossible. So with a haptic glove instead, you can put this on, and then that works like a remote. So the doctor's actually sitting, whatever location, could even be working from home, but still control that glove in the ambulance. Doing the example that we're working with the healthcare industry on is doing ultraviolet scan so that you know where the injury is. And to do that, it's relatively simple in terms of the glove, but you need to ensure that communication channel is pretty secure, pretty low latency when you need edge data centers for that. And then once you reach the hospital, they know exactly what to do for you. And that's just one example of how this platform, this network, that you now for the first time can slice. So remember in 4G and 3G, 2G, all of that, it was very cumbersome to slice the network. But in 5G, you can do that. So that means that it's a huge opportunity for the industry to start to leverage the capabilities of the 5G network for any use case. And this one with the haptic glove and the ambulance is just one. So it's pretty exciting. So if you're young, you don't have to be born 50 years in the future. Actually, it's happening for all of us right now.
Thanks, Ludwig. Thanks a lot. See, another segment from a use case or from a customer segment perspective. So telcos, of course, there are a bunch of use cases which are driven through the telcos, whether we call it the example that you mentioned, which is around maybe medicine or healthcare side. There are use cases that you mentioned on connected cars and other telco use cases. But edge is also something like Piyush had mentioned, is closer to the consumer, right? So which means traditionally if the large data centers are set up in Delhi, Bombay. Bombay still is like 50% of the capacity, or Bangalore, Hyderabad, Chennai. Edge is expected to be many more and closer to the customer, so more in tier 2 towns or more in other tier 1 towns. So there is also an understanding that because, and India is very well spread out, right? Organizations are also spread out, and there are so many SMEs. India has close to 60 million edge data center. And how could actually edge help MSMEs and help organizations in smaller countries leverage the power of cloud, right? The large organizations today, most of them are on cloud, most of them are with the hyperscalers, but with smaller organizations who still don't have the ecosystem to maybe connect with them, get them on the cloud, they may also be having concerns around how far their data is going to reside, whether it is accessible to them from a manageability perspective. So does edge open up opportunities for SME? And maybe Vivekji, if you could try to give us a perspective, as you're from BSNL, you will have the biggest network in all of those towns and ecosystems. So where do you see the opportunity of edge for SMEs?
Yeah. Good afternoon, everyone. I'm Vivek Banjal. I am on the board of BSNL, looking after the cloud data center business and the fixed line business. So if I were to name the title of today's session, I wouldn't have put it age and beyond. I would have put it age and comeback. Now, why I say comeback? My friend has already told you that when he was born, there were dial-up phones and those things. So that time, a telephone was used for calling someone within the city, within the town. There was no STDs. There were trunk calls which used to be booked. So 90% of the people's requirement for the voice was completed within the town. So you had an exchange which is connecting all the people in the town, whosoever has the telephone number, they'll talk to each other. Though it's very well travelable, but you can't travel to everyone's home, 5 times in a day. Then, we have evolved to STDs, and then this world is a global village, and everything is a circle. So our Mother Earth is also a circle. Now with this consumption of the data, where data is generated from the same place and consumed at the same place. As Vidya told, that one of the sector is produced and consumed locally. So we are back to those data exchanges, which are now called with a fancy name like edge, where you need to be, talk to data within the town. No need to go beyond the geography. This, in a very simpler term, what the age means. So I'll say age and comeback. Only thing is, we were voice driven, now we are all data driven. So there is none of, need to go beyond. Connected car is a use case which I am seeing for last 2015, MWC Barcelona, I had seen connected cars. And Google also had tried, then regulations and those, stopped. But I still see a very simple use case. We all have waited on traffic signals at a red light. And every time frustrated that there is no one passing through, but the clock is showing 35 seconds, so you have to wait for 35 seconds. So why can't somebody can read that at what signal, how many cars are pending, so that 35 can be reduced to 5 if there is no traffic on the other side and we can be allowed to go through. That's a very simple use case, which actually needs the age, because you have to read through and then just change the clock and turn the signal red to green or vice versa. That is something which is very easily possible. And why this requirement has come up is because the data consumption for a fixed line, because I have a domain of fixed line, is more than 200 GB per user, even in a village. Right now, I have 500,000 customers who are actually using the data in the panchayats and down below villages, provided by a BharatNet initiative of Government of India. And I am seeing that if he is consuming 200 GB of data in a village, so what kind of volume blast will be required if you say that tier 1, tier 2 town, you have edge centers. I have more than 700 plus district places, 5,000 plus blocks which are next to district going towards the village, and I have 27,000 my own exchange locations. So other than the gaming and the OTT, where you need very low latency, real-time thing, there are a lot of use cases for MSMEs where they need to make sure, only thing is the ecosystem which the fantastic startups which are there in India and around should start looking into it as an application for MSME, as we have millions of them and they are not very big, so they don't have the even mindset of demanding something. But if an opportunity is presented, it will be grabbed by both hands by all those MSMEs. And as a telcos, we are the enabler, because even for an edge data center, what you need is a data environment along with a robust, uninterrupted 24/7 connectivity. Then only it is worth the use. So nobody better than telcos can enable all those fantastic applications and meeting of the demands of my retail customers, MSMEs, small, big, home user, everyone. So there I see that the application for those industries where they can be enabled for better profitability, better productivity, because the number is very large. So a proper application will be very useful, very handy, which the startups should look at it. And as an enabler, we already have such a strong presence. And it was rightly pointed out initially that, telcos have been more immersed in their own data center using for their network. So now we are at a level of saturation that if we want to move beyond for these edge data centers, actual beneficiary to be my end customer is one of the very big opportunity for us to leverage our strength of working, providing and using data centers for a common use. This is the perspective, sir.
Thanks, Vivek. I think one live use case that we can all see today for Edge is the India versus England match, which is going to start in some time. And if you log into your Disney Hotstar, it shows on the top right how many users are connected. And at the point of times, it goes to 10 crores, 12 crores people. Almost 10% of India's population is using that to watch the match live. And that you need good latency, right? Low latency there so that it doesn't hang up all the times. And that's where there is a concept of content delivery networks, right? That maybe whatever data that's coming in is getting reside at multiple places, because if the entire data is residing in top 4 cities and all the network is going, all the 10 crore users are logging into those 4 different cities data center and getting the data, I think that could create real latency issues. So the content delivery networks, which helps processing of the decentralized networks, also evolves, right? And maybe a question to open to here to panelists who would like to take it up on the CDN side, right? That what is the impact on the CDN play, right? Players like the CDN providers, for them also with more and more edge coming in, what is the strategy from a content delivery network that kind of changes, right? And the adaptations that they need to make on the delivery of the content.
I'll just put in for one line.
Everyone wants to jump in.
Just one. For the CDN, I'll just give you one number. 4 years back, we had only 10 locations in India which are providing the CDN content through this age. Today, we have 175 locations in India where all the content is within the districts and provided to all its customers.
So next would be yours.
I was going to jump in with a use case. So I think cricket is pretty popular, yeah? And there's a pretty big match going on today. And there was one use case which we did together with Airtel, which was Kapil Dev. You know him? I think 1983, exactly. 1983, the Zimbabwe match. So that match was recreated using edge computing and 5G. So basically, he came to the stadium as an avatar, so as a hologram, using edge computing. So you could, come real close to him, his hologram. And why this is quite cool is it's starting to show, how we can use, 3D in a much bigger way. And one statistic is how you look at video. How is video being consumed? You talked about how many people are watching, the match, right? So do you think video consumption is going up in the world? It should be, right? Yes, it is. It should. But actually, if you look at single stream video, it's actually going down. The growth is going down. It's minus 55% this year, because multi-stream video, where you see multiple parts of the same game or person, is going up. And you can download from Ericsson.com, you can download a consumer report which shows exactly this, so you can get a lot more statistics. And we're showing it in the booth, actually, where we've got 40 cameras showing different angles of the same. You can bat yourself. You can go there and bat the cricket, and you can get 40 shots of yourself at the same time. So this multi-stream video is really going to put a lot of pressure on CDNs and on edge computing, because multi-stream video, and YouTube launched it now, is just taking off like crazy. And that's only the first step, because then you get the whole VR experience, which is going to show you, much more. So CDN and edge is really going to change with this.
I was actually going to jump in and say, I know a lot of the times we're looking at video and computer vision at the edge. There's a lot more sensors at the edge that you can create situational awareness. So if you think about it, computer vision is great. A lot of this generating a bunch of video, but as you take this conference, right? So you can actually take both computer vision, infrared, all types of sensors, and reproduce all of us together. So we're actually, this is at Intel, we're partnering with Microsoft, as you can imagine, and drawing out a global map of all the users. Call it a three-dimensional view. So you can visualize today, and I'm getting into the beyond aspect of edge, right? So, and take everybody's presence and being able to map individuals globally on a global footprint. But it doesn't have to be camera-based, right? So I think the situational awareness in that case becomes massive. When you start talking about smart cities, in India has the most deployed smart cities. City of Hyderabad with, hundreds of thousands of cameras. But beyond cameras are the sensors. And when we talk about these near edges, edge nodes, about 12,000 of them, just in the city of Hyderabad, right? And it's doing traffic management, the red light signals, it's doing, surveillance for police, it's doing multiple services. And, we're partnering as Intel with a lot of folks implementing that smart cities. But 25 cities in India is the most deployed smart cities. But it's a combination of CDN, it's a combination of video feeds, it's a combination of, one aspect is fun, but one aspect is control, and policing and that. And the same partner of us implemented this full streaming, it's I think multi-streaming, but beyond an event for all awareness. So the same partner of ours implemented this for the Kumbh Mela, with 250 million people converging there, where they're doing traffic management and all of that, right? So the scale in India is significantly bigger, but multi-streaming beyond just video feeds, completely sensor-based, and all kinds of sensors, so multimodality, when you think about audio, visual, temperature, all of that, which is the combination. So that's the beyond aspect. As you go beyond that, being able to traffic manage 250 million people in a Kumbh Mela is not easy. But streamlining, they got a lot of efficiencies. So they're using the same bandwidth beyond the video aspect. And I bring it back to the CDN because now the CDN POPs have gone beyond content distribution to intelligence and compute, right? So I think that's the power of, you have a footprint, how much can you reuse that footprint for the multi-modality?
Got it. Thanks, Muneb. Thanks, Ludwig, on this. And I think one of the important elements that you touch is the security, right? Security of data at the edge. Traditionally, if the data is stored in a single or centralized place, the assumption is that the data will be, it'll be easier to manage the security of the data. But now if the data is getting stored at edge and the infrastructure is so spread out, there is this concerns around data security. So the next question, and with so much of cyber attacks, we've seen bigger organizations also getting impacted through cyber attacks. There's naturally a concern that how do we manage the security of data? How do we manage the, the device updates, all of those, hardware level upgrades that will need to happen with so many devices residing at edge centers. So Saurabh, over to you. Saurabh is director at Dell and CTO at Dell. Saurabh, if you could give us some perspective, and Dell provides a lot of that infra, right, for edge or for data centers in terms of servers, storage, and a lot of that security also needs to come at maybe some security at infra level and maybe some security at non-infra level. So, what's Dell's position? How are you, ensuring, and what do you see as a concern, the security at edge from an infra perspective, and how is Dell really addressing that concern?
Hey, thanks, Alec. So I think before we go on to the security part, let's look at the sheer volume of data that is being generated, that we generate as humanity. So every year we generate approximately 200 zettabytes of data, okay? And the edge is poised to essentially generate half of that. So that's around 100 zettabyte of data. Now, how do you backhaul all of that? Obviously, that's not possible. How do you back up all of that? Obviously, that is not possible either. And every time we swipe our credit cards, every time we do a transaction on phone, every time we try to access an access-restricted office, that's data being generated right there. Or every time our faces show up on the DigiYatra app, right? So that's data being generated right there. So the first aspect is generating with this incredible quantum of data, okay? The second aspect is the sheer geographical diversity in India, right? You've got plateaus, you've got plains, you've got the highest mountain peaks, okay? You've got islands, so on and so forth. And you've got, most of all, the incredible number of people, I mean, the population itself. So the most important aspect is the ability to process data before it becomes stale, right? Data loses value exponentially as its processing gets delayed. So first of all, you need to process it right there and then. And that is where, we are working on solutions which enable extremely high-powered system to run without any climate control at all, okay, very rugged systems. The second aspect is, from an India point of view, if you see the Ericsson mobility report or the Nokia mobility report that comes in, India has the highest number of quantum of downloads on mobile connections on the planet. And we've got the cheapest mobile broadband data, and we've got the most expensive spectrum. So while 5G is there, you can backhaul some amount of information. How do you backhaul all of it? So for that, you need edge. You need to be able to process data where it is being generated. And in addition to that, you need to backhaul only the insights of the metadata, right? There's no point in backhauling everything because it will just completely overwhelm your networks, right? And then based upon that, the security aspect, as Alec, you asked, the security aspect comes into play because as you add more and more edge devices, you've got a threat vector which increases exponentially in surface area. You've got billions of devices which are connected, and those billions of devices, some of them could be used to launch a DDoS attack, right? And that's the incredibly powerful army of devices that could completely overwhelm even the best networks. And that's what we've seen, networks of federal governments being overwhelmed, networks of multiple, multi-billion organizations being overwhelmed, their websites being torn down. So all of that needs to happen through, all of that needs to be safeguarded through having synchronized updates, as you mentioned, okay? We update Android devices and Apple devices every quarter, if I remember correctly. Apple keeps on releasing their updates every few weeks, every month or so, okay? And then we've got mobile applications, right? So those keep on getting updated every week. I mean, you see a new version of Netflix, or you see a new version of Dropbox or Microsoft Office every couple of weeks. So what is essentially happening? You're basically securing the application, because nothing is 100% secure. And for that, you need to have cryptographically encrypted updates, which is what we offer on our solutions, okay, which are available from a data center point of view for managing the entire data center, as well as each and every discrete edge device. Thank you.
I'm going to add to, hey, Saurabh, absolutely right. The attack surface at the edge is massive. Like usually you could have, you know, in a data center or cloud, massive firewalls where you can secure it. Here it's completely open. And we're partnering Intel and Dell in doing what we would say is secure device onboarding, which is fundamentally, you know, a lot of the times you come down to where's the root of trust? Because everything needs to be validated through a root of trust. And the partnership with Dell and Intel here is really we're putting the root of trust at the silicon. So the fundamental notion is you will have application developers write applications in the data center or cloud. You're not going to be having developers writing at the edge. It's written there. What becomes a challenge is how do you establish a secure software supply chain from the data center or the cloud to the edge? If it's always running at the data center and cloud, you don't have a security issue. Like you have a security issue, but you're protecting yourselves with firewalls, et cetera. Once this gets pushed out, the secure software supply chain is attesting every part of the infrastructure, leaves the cloud, the data center, going through a telco network to the edge device and the near POP to the device itself. Every point, attestation of the application, attestation and securing this, because every point is a point of vulnerability at the edge. So as we do the partnership with Dell and Intel, we actually do this attestation right at the factory level. So if you followed the FIDO Alliance, which is an alliance for security at the edge, so we had done secure device onboarding, but now we've evolved that into, so right at manufacturing of every Dell hardware and the silicon, there's a certificate that goes in, and there's matching as these roll out with the zero trust parameters. Even though at the edge, you may not have an IT person, when it arrives, those tokens are passed through from the factory all the way when it's deployed with zero touch provisioning, because you have no IT people, right? So that amount of effort, both, you know, again, Intel and Dell is probably the first to deploy FDO at scale at the edge. And if you don't get to that, you get pretty, you know, compromised devices and nodes.
Maybe if I, no, go.
So just one thing, I think in addition to the security at the physical layer, at the chips layer as well, you need security at the application platform layer as well, because actually all the access and everything which has happened to the software platform application. So at Red Hat, we make sure, because we are based on open source things, so that we bring best of the innovation from the open source communities. And we make sure that we make it enterprise grade, because the kind of vulnerabilities, you'll be surprised if I tell you the number of vulnerabilities we kind of solve, security vulnerabilities from the open source project we solve to make it enterprise, like 2,000, 3,000, you know, software threats, which we resolve at our platform, right? So that's the power of open source there. And one very important thing we all need to understand, that edge is all distributed data center. It's good to have secure platforms, secure infrastructure, but if at all there is a threat which needs to be mitigated, you should have ways and means of, you know, deploying the mitigation from a center location and all at the same time. That's where the role of orchestration or the automation comes into picture. So we do have an Ansible automation platform, which is amazing orchestration from the center location, you can push the security policy to all those distributed data centers simultaneously. So that's another thing which is very important. I think there's just automation of the security mitigation, at the same time making sure the platforms are secure. Thank you.
Great, thanks Piyush. Ludwig, you want to say something?
Yeah, I was just going to bring back security to the consumer. So we talked about slicing. Slicing is an amazing way to create secure part of the network, and the ambulance example is one which really brings that, to its fruition. But there's one problem with it. And the problem is that we're talking about standard slicing. Standard slicing means that you give a priority to one user, in this case, the ambulance, right? But what's really cool is a new abbreviation. I don't know if you know URSP. Have you heard of URSP? It's UE, Route Selection Policy. And why is this abbreviation pretty cool? Because it allows you to have multiple slices on the same device. So you can have different security settings, of course, for these different ones. But it also allows, so that means that if you push one of the applications on your phone, if you push Teams or Zoom video, for example, you could set up a slice for that. So there's multiple slices to the same phone. And why is that super cool? Because you and I, we don't want to pay more money for our subscription every month, but still, we want to have better and better services. So by having this, it allows our customers to have an additional revenue stream which doesn't have to come from the consumer. It could be, Zoom or Microsoft that's actually paying for that slice to be set up for their service to be pretty good, like a cricket match or like the Zoom video or the ambulance example. So with URSP, which is available now from iOS 17 and Android 12 and 13, it really allows for the possibility for edge computing to flourish, for security to be for individual use cases, and for more revenue to come into the players in this industry. So pretty cool.
Thanks, Ludwig. So I think with all infra level, platform level, software level security, it's safe to assume that the security at edge is pretty much taken care of. Okay, so we are almost at the edge of time. I'd like to open it to the entire hall here, to participants in the session room. If you have any questions, you can just raise your hands. We'll have someone pass on the mic, and you can address the question. You can either it can be the question to the entire panel, or if you have any specific question to any specific individual, you can mention it and then mention a question.
Yeah. Okay. The question specific could be to the Airtel or the Ericsson. Sorry, I'm not using your names. But what I wanted to start off was, from the Linux point of view, you talked about the open source at the application level of security. What you covered at the Dell was keep having refresh and keep having those latest updates which are coming out from the security point of view. And at the chip level, we are talking about some security which was mentioning. You talked about network slicing, some kind of protection, and that better route which is there. My concern, which I would like to just clarify, is we are talking at the edge. And at edge, it's going to be totally wireless. And at wireless level, we are going to have miniaturized things with lesser power and try to depend on one base station or two base stations or three. This is my thinking on this particular issue. So what happens if that particular RF level interferences are there? So all the edges are going to be out, and it's going to be a major security issue when so many devices are out of any connection. So not exactly the security from content point of view. The security from a RF point of view, where you may have all your edges, the devices, going out of the connectivity. That's the question.
Maybe I could start if you want to add later, Vidya. So first, 5G is the most secure of all of the Gs, which is pretty good. But you're right, there's more devices, there's more interference levels, and really, just like your phone is updating the applications. You don't know what version of WhatsApp you're using, you don't know what version of Teams and so on you're using. It's really important from a security level, even though the technology is secure, you need to ensure that the applications that are running on the network, both the network, the CNFs, but yeah.
Talking about the RF interference, which is going to make your device non-functional.
Yeah, no, exactly.
That's the question which I'm putting.
Yeah, no, exactly. So therefore, it's really important that the network, not the applications on the phone, but the network also does continuous updates, just like the phone does. And there is another abbreviation, which is ISSU, so in-service software upgrade. So the network needs to be continuously updated, which is what this technology provides.
So let me take a stab at answering your question, okay? So first of all, from a 5G point of view, what increases is your spectrum, right? So you've got significantly more spectrum. Let's say, for example, on the millimeter wave, you've got 1,000 megahertz. On FR1, which is below the mid-band, you've got around 100 megahertz. If you remember, in 2G, we used to have
the edge device cannot have all the spectrums. Edge device will be at a particular
Would you
place.
please let me answer the question, sir? Yeah. Okay. So first of all, from a technology point of view, you've got bigger bands, okay? Then you're using incredibly higher order modulation and encryption, okay, to push the updates. You've got AES 256-bit, you're moving on to AES 512, so on and so forth. So your encryption is also increasing. And why is your encryption increasing? Because every time you increase the encryption, you need more math, right? And that is where our friends from Intel are building in solutions which consume lesser power on the battery, okay, so that it can run for a longer period of time, okay? In addition to that, you mentioned interference. Because you've got so much more spectrum, you might not need to use the entire band, okay? For example, in NB-IoT, you use a much smaller part of the band, but because you've got a massive swath of spectrum, you can, essentially push devices on different frequencies within the band or different codes within the band, right? So that is how you mitigate the interference piece. Then on 5G, again, okay, for devices which actually do need significantly higher bandwidths and are tethered, okay, or, because look, edge devices could be nomadic, edge devices could be fully mobile, edge devices which are fully mobile will obviously have a power source commensurate to their mobility options. Nomadic devices will obviously be plugged in most of the time, and stationary devices will always be plugged in either to something like a solar-powered generator or DC or whatever, right? So those devices will have the ability, the compute, the resources to sustain that communication, okay? And that is what is essentially, perhaps trying to answer your question, okay, that is what is built into the technology. And in addition to that, what Ludwig also said, so when you look at network slicing, one slice is completely isolated from the other slice, okay? You cannot even ping, so there is no reachability unless you create it so, okay? So that is where, even though, let's say, you and I are doing some activities on the same band, on the same spectrum, on the same, in the same location, we're completely isolated. There is no way that I can hack into your slice. Does that answer your question, sir, or would you like me to? Thank you, sir.
Thank you. Any more questions? Any other questions, please? Okay, if last call out, guys, any other questions? Otherwise, then we can call it a session. Great. Thanks in that case. I think it was a great interaction. We started more from the understanding what is edge, the business potential of edge, the business elements of what's going to drive edge, and then we moved at elements around security, around efficiency at the edge. I think it was a great discussion. Thank you so much, to all the panelists. It was a pleasure listening to all of you and especially hearing both on business, especially a lot of technical elements which are new for me as well. I hope I hope you liked the session. I hope it was useful to to whatever extent to all of you. And thank you for joining in. Thank you very much.
Thank you. Thank you so much.
The topic for our discussion is, as you can see, edge and beyond. This is the part B of it, where we are going to talk to some of the doyens of the industry on how 5G and edge computing is changing the data center industry. You know, the convergence of 5G and edge computing is fueling innovation across multiple sectors in India, and some of these we're going to discuss today. What challenges are presented by this fast pace of innovation, where you require a considerable amount of infrastructure investment and spectrum allocation across board, is something that we need to figure out. Some of these challenges could be, you know, workforce related, investment related, as I mentioned, spectrum related. And also we'll try to address a sort of a digital divide which is coming through if we get time. But this synergy of 5G, edge, and data centers, what it does is it provides you with a lot of enhanced connectivity, which is faster, low latency bandwidth. So with that, let me introduce you the esteemed panelists that we have. It is an absolute privilege for me to be part of this panel, along with some of these leaders of the industry. We have Shri BP Singh with us. He is the Senior Executive Vice President for Cloud Business Platforms and Services for Reliance Jio. Mr. BP Singh has been instrumental in building world-class hybrid and edge cloud management platforms available on SaaS as well as on-prem platforms. He comes with extensive experience in building scalable business platforms, deploying complex solutions, and managing the life of such large clients. Before joining Jio, he was an executive director at IBM. Next to him, we have Mr. Gulshan Khurana. He is the executive vice president for transmission and core planning and technology at V. He is a former Reliance executive and has also led sales and consulting in Asia Pacific and Japan with Oracle. So he comes with 3 decades worth of experience in this industry. Next, we have Peter Weglitsky. I hope I'm pronouncing it right. He is the product marketing manager for AMD. He leads the telco segment in the AMD server business unit, and he's got over 2 decades of experience in semiconductor industry, focusing on networking and telecom solutions. Prior to his role with AMD, he held a number of business development and systems engineering and marketing positions across Motorola, Freescale, NXP, and AMD as well. Then we have Sardar Burrell. Burrell has an expertise in wireless technologies and software development. He is the product manager for telco at Canonical, the company behind Ubuntu Linux systems, which all of us have used growing up. It provides open source, full upstream, secure, cost-efficient, and carrier-grade infrastructure solutions for telcos. He has previously worked in the 5G Innovation Center at the University of Surrey. Then we have Dr. Guru Prasad. He is the head of excellence, IoT edge and connectivity and technology strategy at Bosch. Dr. Guru is presently responsible for technical strategy for Bosch India, driving center of excellence in the edge and connectivity space. His technical expertise includes innovation strategy, technology strategy, sensors, instrumentation, digital transformation, and data analytics. Then we have Mr. Pradeep Nair. He is the Vice President and Managing Director for India in VMware. He leads their sales and marketing operations in the region. VMware Telco Cloud Platform combines a suite of products and services to help CSPs modernize and virtualize their network, and ran by deploying power of automation and orchestration with multi-cloud platforms, edge computing, and private MEC 5G. With that, let me start the panel with Mr. Brijpal Singh. Mr. Singh, we were discussing outside about the advent of edge and 5G in data centers. What do you think is the primary driving force behind the need to redefine these 10 data centers?
So there are,
please.
Hello. There are 2 major factors. First is rapid evolution in data center technologies. And the second is growing demand of data center infrastructure, which includes compute, storage, network, and many more business platforms which are required. There are several regions which contributes to this particular need. The top factor is explosive data growth, which is, as we all know, human and non-human. Every single thing consciously or unconsciously is generating data. So even while we sleep, our mobile phone does the talking, or even while we speak, this data is getting streamed. And hence, there are tons of business cases which have emerged. That forces that this data actually gets processed as early as possible to generate necessary business insights so that this data can be monetized. In fact, our chairman, Sri Mukesh Dhirubhai Ambani, identified this few years ago when he said that data is new oil. And that actually phrase is proving to be true. Data as such actually has been there since many years, or even in the ancient times. It's just that availability of data and the processing of data wasn't as easy as it is today. Even if, when you look at some of these algorithms or the, which we call AI, ML, or regenerative AI, the fundamental models are actually mathematical in nature. So they had been there, Look at all the books which are there. They are in 1950s and 1960s. So all these capabilities had existed. It's just that we didn't have the capability to extract this data and process this data and make some sense out of it. So that has happened now. And that is actually forces with quite a few constraints on the data center of the digital infrastructure. The second main factor is advancement in technologies. So today, with the advent of regenerative AI, analytics, big data systems, IoTs, there is a constant demand of different kinds of infrastructure. So the infrastructure which used to foot the bill actually is not enough. Today, all these latest technologies, they need GPUs. They need different kinds of data center capabilities. Erstwhile, there used to be data center which used to have, say, one rack with 5 kilowatt. But today, 30 kilowatt per rack actually is the norm. And reason for that is because the business demands is changing. You want to process that much faster. The third is energy efficiency and the sustainability. So with the growing awareness across the world, data center models actually are being changed so that they become green and they become, carbon foot efficient, right? So that we actually meet the sustainability standard. In fact, this particular area, when it comes to sustainability, it is not only changing the data center models, but it actually changing the technology architectures, the way business applications and the platforms are being built. So just for example, when you build an application, right, you might build an application which is most optimal, or you might build an application which is not so optimal. So when you build application in the core which are not so optimal, they end up using more compute. What that results into is more energy. And hence, this paradigm of sustainability actually is putting constraints. How do you build data center? How do you build your applications? And how do you kind of, manage them? Because if you don't manage them well, then they are going to be less and less efficient. And hence, these constraints actually are being laid on the data center technologies as well. The next is the scalability. Today, there is a need that data center can scale up and scale down depending on the business needs. So that has led to a different form factor of data centers. So, you must have heard of modular data centers, which can be, plugged in a space of 30 days, and they are kind of, operational. But that puts many other constraints in terms of how do you manage its power, how do you manage, cooling, how is the efficiency, how do you guardrail the physical security of these smaller, sites which can be plugged in anywhere. The next is the edge computing, right? So there is a demand, and this is no different. These models actually are repeating in itself. A few years ago, when big data came into picture, there was a, advent of Hadoop. And what did Hadoop do is brought data closer to the compute. So while it's kind of losing its sense today, but that's exactly happening on the edge as well. Compute is moving closer to where the sources of data are, so that the relevance of that data actually becomes more relevant. So with respect to different industries, there is some data which has got its relevance. If you process it in, let's say, next 5 minutes or 6 minutes, it loses its significance if the processing time increases. And hence, edge computing is putting constraints as to how do you build all these capabilities on the edge, which is closer to the, data sources. Next is security and compliance. Now, with cyber threats coming into play, so there are quite a few regulations in different countries, GDPR, CIPAs, and they are putting constraints in terms of what kind of security guardrails your data center has to have. All right. The next big factor is cloud connectivity. So gone are those days where you could build applications, either they were on-prem or they were public. There is a demand where applications actually have to use best of both the worlds. So a part of the application can run on-prem, part of the application can also run on public. And hence there is a need of hybrid cloud infrastructure, and that puts, again, certain requirements on how do you build your data center, infrastructure. Resilience, redundancy is another key factor, because expectation is that these data centers are resilient with respect to any turbulence in the environment, so that they could deal with it. And they have to be available all the time. So availability is given, like electricity and water. Nobody questions those things. They are available to everybody. Digital transformation, which is causing every enterprise to rethink, to redesign their applications. All right, and everybody wishes to make use of best of the capabilities across how much you put on-prem, how much you put on edge, how much you put on public cloud, so that the whole, the delivery to the business actually become more and more efficient. So these are, some of the reasons which are really driving the innovation which is happening. And innovation in data center space actually are happening every single second in terms of making them efficient, making them modular, speed to go to the market in terms of plumbing your data centers. So these are some of the key factors driving the architectural changes in the data center space.
Yeah.
Thank you.
Thank you. So you touched some really pertinent points on scalability, sustainability, and the location is a very important part of a data center. So with that, I would like to ask Mr. Gulshan Khurana as well. So basically, when we are talking about edge data center, availability has to be good, your sustainability feature has to be good. So, how crucial is the location of that data center per se when it comes to high connectivity and a sort of low latency rates? That's what the current industry is moving towards, right?
The entire crux of discussion happens to be on what should be the ideal location, because we have centralized data centers, everybody has. We all serve our consumers, millions of consumers. So why this debate happening on where should it be placed? As you rightly said, Mr. Singh, very correctly, the data analysis has to happen closer to a consumer where data has been produced. That's very important. This is where the entire discussion started, where should we put it? The second biggest important part which plays a role on where should the data center be is the consumption. The data production is happening in leaps and bounds. I mean, we have seen the data handling nodes are going to 400, 500 GPS. Do we actually build smaller nodes, bigger nodes? Where should we put them? Because consumers' consumption is most important. I need to find a balance where I put my data node in. Do I put it in the centralized data center? Do I go close to consumer?
it will purely depend on the consumption pattern, consumption requirement of the consumer. Is an application which is very, very high in throughput, requires low latency, of course I need to go close to the consumer. But then there's a cost. So economics has to play a very important role. Where do I go? Do I have 2 locations, 3 locations, 5 locations in every PLMN, which is close to consumer or in a centralized database? Cost of the transport, which is to be built to handle this data, and service analytics to be done on the data will play a very, very important role. If the service consumption requires high amount of analytics, is a very, very extremely high throughput, requires low latency, I need to propose close to the consumer. But is the consumer paying for it? Is the revenue enough to build so many? So this was a big battle between when the public cloud came in saying, okay, we can do it as a low cost, we can do it on a pay-as-you-grow model, we can do highly modular structures, but the reach is a difficulty for them.
Correct.
We as telcos, we have a reach. We have more than 120, 130, 140 locations where we can serve. But then does it make economic sense? So I think to summarize the discussion, service consumption, service analysis, number of bytes being consumed, does it make sense to go close to consumer? Or does it make sense to keep it back on a centralized data center on the cost of transport, on the severity and the need of the consumer would define the locations?
Yeah, I mean, consumer journey, like any other industry, is extremely important data center industry as well. And with that, I would like to ask Peter, this whole customer experience, and how will it change, the end user customer experience? How will it change with edge computing coming to data centers?
Absolutely. So this is a great question. How the benefits that our features of the edge are going to be actually passed as a benefit to the end user and to the consumer. And I think that there are probably 3 areas that I would focus on. The first one I would call richer and fuller experience and services with increased performance and closer to the user with decreased latency. Such activities like online gaming, for instance, AR, VR activities will become much more real and much more, more immersive experience. Also, because there will be tailored services and location-based services that will give extra experience to us as consumers. Tailored services, we experience this already. When we finish a movie in a streaming service, we will get a recommendation immediately about other movies which, are based on previous history, on our preferences, and so on. The same thing goes with for instance, news information and services. But because the data center, edge data center serves a certain geographical locations, you can get services that will be very relevant to the consumer. So things like, which are very specific, to the situation that is happening at the time, whether it's a weather, traffic situation, events that are happening in the community, at school, you can get this type of notification and get a better, visibility of what is available and what you can do. Also with the location-based services, proximity marketing comes into play as well. For instance, if I pass a store that I shop in and edge compute infrastructure really senses that, they can push the notifications to me about new offers in terms of products, rebates, and coupons and this type of thing. So again, gives us this more information which is very relevant, which we can use in our decision making. So that's one area. The second area I would call peace of mind. And that comes with the fact that both the security and also the privacy of data. The fact that our personal data will be stored not in some other geography, but fairly close to where we are. It gives additional peace of mind, actually, especially that there will be a lot of sensitive information like health information and other, which is quite important to us. Another one which is maybe not as intuitive from the experience, direct experience for the consumers, it will be a data bandwidth. if we communicate with the data centers hundreds and maybe thousands kilometers away, this massive traffic is going back and forth. If this traffic is more localized, then there is service providers get a little bit of relief, and they can really plan the networking usage in a different way to provide the better services. So that's the second area. The third area I would call new services. And there is a number of new services that will be coming, So for instance, the first one in the enterprise, there is more and more private 5G networks that are coming up. We were talking with Guru exactly, sort of a few minutes ago about that. And what is interesting is actually, the fact that, with many of these private networks, especially in manufacturing, you need to have real-time processing, data processing. You need to have data analysis done immediately and decision made quickly. If you've got moving robots, manufacturing cars, for instance, you need to have this real-time capabilities that edge compute really offers. The same thing in warehousing. If you're using robots or if you're using, for instance, drones, collision avoidance is absolutely key. So you need to have these real-time capabilities. For the consumers, on the other hand, retail will be a very interesting area that will be developing and will be really leveraging a lot of edge compute as well. You know how, for instance, shopping for clothes, it's typically you browse things and you go to the fitting room and all that. It can all be changed with AR and VR. You will be able to really see yourself in a new piece of clothing and change size, color, different style, sort of immediately. So this is a much, much better experience. It is also very beneficial for the retailer as well. They don't have to carry all of the inventory there. You select a piece of item, a piece of clothes, a new item. They will order this online, will be delivered to your home. So this is a win-win situation on both sides. And my maybe final example I would give is in education, and again comes from the AR/VR. Can you imagine how enriching education will be with using AR/VR, for instance, in the history lessons, when students could be transformed like 400, 500 years back, and be eyewitnesses, some battles, witness some debates in the parliament, watching, the ordinary life. Of course, there will be a lot of content that will be needed to be created. It's a question if, as soon, rather, when is it going to happen rather than if it's going to happen. So the capabilities that edge computing is providing is definitely going to enrich our experience as consumers.
Yes, thank you. Some of this customer journeys that you talked about does require a movement away from your traditional models as well, and that's where I come to, Viral. At Canonical, you are, Viral, you are known for moving outside the traditional models across. So, when it comes to edge data centers and and their potential impact, what are your thoughts around that? How do we move away from the traditional data center model on this?
Thanks very much. Previous speakers also talked about a lot on the effect of edge compute and the need for edge compute. It's essentially about bringing better performance to end users so that they can have better quality of experience of any service they receive. So the idea for edge compute is essentially enabled businesses to also provide their customers with better experience, but at the same time, maximize their profits, so maximize their operations, automate their operations better, because then you have this close loop of interaction between a business service deployed at the edge and their devices and their users, essentially. So edge compute, in that sense, is a driver behind edge clouds. So basically from the core cloud where you run all the services at a single place in a massive data center or perhaps cluster of data centers, now you basically push all these services to the edge of the cloud, edge of the systems, closer to the users and devices. And in doing so, you can establish your services closer to those end users and basically provide them with better services. So what is the change here? Essentially, the change is to improve service, but at the same time, you need enablers to make this happen. So when you have data centers distributed around the country, closer to end users, you need data centers as well. That's where the edge clouds come from. So to enable that, obviously, you can have racks of servers where you're running your systems and services, but if those systems are actually fixed services, so basically you run and install them once and go away, that will not solve the problem. So you want some sort of flexibility, some dynamism in deployment. That's what businesses are looking for as well. So when you have an application deployed at the edge, you want this deployment dynamically done and then automated as well. So automation is really important in terms of services and services provided. Also automation in terms of life cycle of the events that the services you provide. So you deploy, you automate the deployment, and at the same time you automate the life cycle of your applications. To provide that flexibility, as you know, there is virtualization platforms that come into place, such as OpenStack, Kubernetes, and all types of virtualization systems come to our help, because we can now run services and applications in real time as a virtualized service. So you deploy them in real time dynamically, and you'd also orchestrate their operations. That means you need systems, that dynamic system at the edge of the network that can carry this kind of services as containerized cloud-native functions. So that means you need this kind of virtualization systems, but at the same time, these systems need to work in an automated way, in a secure way, in a minimal way. Because the edge cloud is not really essentially the same as the central cloud. Your scale is different. Your number of servers there is different. The availability of your staff to service those sites is also different. So the business model is different. That means the systems must be autonomous. They must be secured, and also they must operate in an autonomous way. To provide that, you also have inbuilt security. So security in terms of your operating system, in terms of also the virtualization system you run on. So you need to secure the site services running there. This is especially important for 5G services, because as you know, in 5G communication systems, you have disaggregated services. So basically, your core network is now distributed across the country. You can run your data plane closer to the edge. That's also, again, about improving the performance. Because data plane performance is so important in telecommunications that end users want fast service, right? But also business want fast service. Piotr initially talked about private mobile networks. This is so important now, because edge computing has such correlation with private mobile. Enterprises will want that capability. They want that real actionable outcomes on their services and really close interaction with the devices. That means you need really real-time systems, real-time from all the way from operating system all the way to systems. So that enablement from silicon all the way to your application must be there, so that your interaction with your services and devices will be fast. So if I want to summarize that, edge clouds bring performance to users. They are large in number, they're close in proximity to devices and users, and they will be distributed around the country. And you want automation systems. You want repeatable and automated deployment experience for your applications or also for your services. And they need to have the latest improvements in terms of performance, such as real-time operating system.
Thank you. That was fantastic. Now, of course, there are a lot of risks that you talk about, Viral, and some of these risks and problems, edge data centers, edge compute data centers do, Dr. Prasad, they do occur in an IoT-based ecosystem, right? So what are your thoughts around that?
So good afternoon. I'm Dr. Prasad. I come from Bosch. There are two major roles Bosch is playing in edge and 5G ecosystems, especially in India. One in the sector of non-mobility, where we look at factories for future. We are end users of edge and 5G, where we are expected to completely automate the entire shop floor, where we run millions of parts per minute, and then drive efficiency in such plants, where we are end users of this entire edge and 5G. On the other side, where our bread and butter lies is mobility, where we connect cars, where we talk to OEMs to provide this technology. In this space, we work as technology enablers, as Tier 1 companies to enable Mahindras, Tatas, Audis, BMWs of the world. So let me put my perspective. I think Mr. Singh and Mr. Peter has very clearly covered the essence of edge compute and 5G. But if I summarize both of them in one sentence, traditional IoT systems today are limited by majorly 4 issues. One is latency. I think what is latency is addressed. Second one is bandwidth of the data or the network. Third one is cloud storage cost. And fourth one is data privacy. If you look at edge compute, I think it does any one of them or all of them. Now let's come to a particular case of mobility. By 2030, most of the analytics says every car on road is expected to generate about 5,000 GB of data per day. Just imagine 5,000 of GB of data every day per car if you want to analyze. And the expectation here is you want to drive car autonomously on roads, which means you're looking at least L4 and L5 ADAS functions. And what is the expectation here? The entire inference, I'll explain you what is inference. The entire inference is expected to come before 20 milliseconds for you to take actions, right? So let's now go to the traditional IoT stack. We have sensors at the bottom layer, which grabs this data. You have acquisition units, which collects this data. You have middleware, like an operating system and middleware, which takes the data from the sensors. And through the network, you push this data to cloud. This is one way. And in the cloud, you have a fleet of AI algorithms. Let's take an example of a camera on the car, right? It gives you 15 to 20 frames per second with high resolution data. Just imagine if you really want to drive your car with CV-based application using traditional IoT, which is cloud-based system, God must save us, right? This is where we are looking at alternative technologies to cloud, which helps us in addressing latency, cloud bandwidth, cloud cost, all of them. So what we are looking at is bringing certain architectural changes in the IoT ecosystem. For example, I think people are also talking about what is edge, right? When you talk to a sensors company, they say my sensor 5 years back was just a dumb sensor, which was giving me an analog output. Now I have brought intelligence into my sensor. I have bought a small capacity of data storage, and now I call this sensor as an edge sensor. When you come to somebody like telematics unit, which actually grabs, or you can say a gateway, right? They say any system will actually have a circumference in which the last entity is gateway, which means the entire system data gets accumulated at the gateway, and the gateway sends the data to cloud. Now, before sending this data to cloud, you run your analytics in real time using all the technologies what we have mentioned to ensure you neither ship the raw data nor wait for the response from the cloud. And then run your analytics on the device itself. So I'll take a last example of a car. So if you look at car, you have engine control units, which is ECUs. Next, you have zonal computers, where you have multiple ECUs connected to a zonal computer. Next comes vehicle computer, where for an entire vehicle, you have one computer. And then at the end, you have a telematics unit, which actually sends the data to respected cloud, which is through GSM, XYZ. Now, what is edge in this context of mobility? If you run your AI loads, for example, I have a sensor, which could be camera, connected to an ECU. If I run my AI loads or AI models, taking the data from the sensors in the ECU itself, I'm talking about the first layer, in the ECU itself, that could also be edge. Super mission critical, time critical.
so that network optimization, many of the 5G features, they get enabled. So this is first layer. The second layer is where as compute technologies comes into play. So there, the first thing is, how do you manage this whole thing? Because in remote facilities, you would not have too many people to take care of it. So the full orchestration of edge resources, monitoring, managing of them, taking actions if something goes wrong, that has to be done at that layer. Next layer is the processing layer. Sorry, the containerization and the virtualization, where VMwares of the world, Red Hat and Nutanix, some of these partners, they come into play. They got all those capabilities which can be leveraged there in terms of having K8s, K3s, and the virtual machine getting spawned up. Next is real-time data processing, so that as and when this data is getting transmitted, so you got all the capabilities in terms of messaging bus and the capabilities in Kafka and many of those technologies, which allows you to do local processing at speed. And at that layer, the last is the AI and ML capability on the edge, which our co-panelist also mentioned. Because one thing is very fundamental, and that's why he said that as has got different definitions. All right. So it depends as to what is the value of this data. Right. What is the time after which this data loses its meaning. So some data is like critical, saying within few milliseconds you go to do whatever you want to do. Otherwise, beyond that, there's no relevance of that data.
Correct,
right? There could be some data where probably it has value maybe for 300 seconds. Service provider perspective, it becomes even more complex, because if you are serving different customers on the edge, so then, rules of multi-tenancy, how do you, produce bills to them? How do you build capabilities in terms of customer A may want X number of capabilities in terms of products, which they may want. Customer B may want something else. So that's where this whole complexity involves.
Mr. Khurana, your views on this? As a service provider, I mean, it's essential. Yeah.
Whole 9 yards. So I'll, not for the sake of repetition, I'll pick up the most important aspects that I think are important from our perspective. I'll start with a logical approach, saying, why did we start building edge first of all? It was requirement of latency and throughput. Everybody knows that. So the equipment infra changes required are to support low latency and high throughput. They should be capable of doing business analytics and service analyzation, so that whatever the customer requirement for which we put the edge there should be done. I should not be taking all my. You touched upon a hybrid piece where the data is co-hosted between an edge location and a central location. I would rather say it is multi-tenant as well, because it is a land of now startups coming up, and each one of them would not be able to put up their own piece of private network and edge network. So we should be very careful every case. Edge for a multi-tenancy solution, you should be able to manage in such a way that everybody has a secure piece available to them.
Correct.
So these are 3 pieces which are very, very important for me to manage. One is infra, to give service to the consumer, analytics to the consumer, service consumption to the consumer. Number 2 is maintaining their sovereignty. Number 3 is management in such a way that not only a hybrid structure of hosting workloads on different locations, different clouds, but also multiple tenants in the same cloud should be able to be managed through this infra change. So you touched upon all. I've taken 3 of the most important pieces which are important to me.
Yeah. So I want Pradeep and Poiter also to kind of weigh in on this. Both of your organizations need to probably catch up, or already are at the forefront of this new architecture which is coming up in data center, right? So, and VMware and AMD have a very big role to play on this one. What are your thoughts around this?
So let me start with a processor. Everything starts with a processor, effectively, So I'll take a credit for the industry, because we don't make it happen, but we definitely enable. So let's think for a moment about mobile phones. The processing capabilities of these devices a few decades ago would be only done by a few racks of servers, which would consume, tens, if not hundreds of kilowatts, and would cost hundreds of thousands of dollars. If we did not make such a spectacular progress, the devices that we use right now would not be a reality. And, it goes for all of the, technology effectively. But what it is with the semiconductors, there are two things that, the advancement goes in. First is innovation in microarchitecture. So making a processor much more efficient and much more performant within a power envelope, And effectively what we've been looking for is provide maximum performance in affordable power and affordable cost. So one is the microarchitecture improvement. The other one is using the latest semiconductor technology. So in other words, how small is the transistor that it's building the microprocessor. And just to give you an idea, when 68000 and x86 processor started, it was about probably 2 to 3 micrometers. Okay, that was the technology. So it's 2,000 to 3,000, depending on a point, in history, nanometers. When I started my career, the devices were manufactured in 0.65 micron, which is 650 nanometers. Today, AMD is shipping devices with 5 nanometers technology. Yeah. And what it means is basically we are bringing exactly that, this performance efficiency into data centers and into the edge data centers as well. In edge data centers, infrastructure, there are like 4 main factors that you really need to drive to. Maximum performance within a low power envelope, and for a server, of course, there is a certain power budget. For processors, typically is about 200 watts. Then, of course, there is a space limitation in most of the edge locations. So, servers needs to be a shallow depth and, be able to dissipate all of the power. And then the fourth thing is, the cost, which is much more challenging. So we are developing specifically the devices to do exactly these functions. So AMD has released a product only a month ago, EPIC 8004, which is exactly putting an extraordinary number of cores. Right up till now, the industry was able to do about 32 roughly processor cores in 200 watts. Right. We are doing 64 cores in 200 watts. In data centers, what we are fighting for is the compute density. What Gulshan mentioned about the power rack, power limitation, which is 30 kilowatts. So the key thing is really to load as many processor cores as you can into that. And through that, you will be achieving much better power efficiency, which translates into saving cost, but also it will translate into sustainability.
Right.
So these are the key factors for us.
Pradeep, your thoughts, please.
Yeah, thanks. So a couple of things, right? So once, as you get closer to the edge, you want the ability to run the same applications that you're running in your data center at the edge. And so that's the first key thing that we do as VMware. We help deliver an edge compute stack which is stripped down bare bones at low power, which is able to, allows you to deploy the same applications that you traditionally run closer to the data center. So you don't have to refactor, rebuild, rewrite your applications. At the same time, if you're building what we call edge native applications, you have a stack that's optimized, that is available to be deployed at the edge, that you can take advantage of. So that's the first thing that we do. The second thing that you look for as you look at these changed architectures that BPN talked about is the ability, as we get close to the edge, traditional applications or traditional architectures usually have to deal with what we call IT applications. As you get to the edge, you also have to deal with what we call OT applications, like what Bosch talked about, right? And so to be able to have an orchestration layer that manages or has the ability to orchestrate devices across all of these platforms, your traditional IT applications, your OT applications, the architectures are usually different. Traditional IT architectures usually have a push architecture where you push out updates. OT applications usually have pull orchestrated architectures where you seek updates that are required. So these are different, and so can you build an orchestration layer? And Jio seems to have done some of that themselves. But we would argue that, can you build out an orchestration layer that enables you to manage infrastructure, networking, and security across these disparate platforms with one single console? And that's, again, something that a lot of our clients are asking for, and that's, again, something uniquely that VMware offers. So as you build out these architectures at the edge, you have the ability to, one console that rules them all. So these are the two things that we look for, an edge orchestrator and an edge compute stack, and both of these we I think can deliver unique value as telcos and service providers look to roll out these applications.
Thank you. Virul, what are your thoughts on infrastructure development which is required? I mean, considering the third most visited website in the world right now generates 5 petabytes of data in a day, so that's huge. So, I mean, you and Dr. Prasad, both of you, if you can give your viewpoints on that, yeah.
So yeah, in the infrastructure side, obviously, in terms of 5G services, I mentioned previously that these are microservices based, and your data plane is now closer to the edge of the network. That means you need to run in 5G user plane function, and there with the Open RAN elements such as central unit, distributed unit, and remote unit, especially distributed unit, they will be closer to the edge of the user. So you want to have basically enable these data plane functions faster and faster. And that is the key to enable higher data rates. So that means if you want to make your data plane faster, you also need to make sure that your system uses enhanced platform features as much as possible. Piotr mentioned silicon advancements. So basically silicon is always making sure that their architectures are aligned to expedite processing of tasks so that you can bring that real-time performance. But this also has a full stack implication. So from the application all the way to the user, you need to basically streamline this delivery of the data when the amount of data and the types of data also differ, because on those systems you will run IoT systems that deliver data at certain frequencies, at certain time periods. At the same time, you will also have some application that stream the data in high rate. So they live together. So you would need to have a platform that can enable microservices-based deployment of these, at the same time consume the platform's enhanced features. So for that, basically, in Canonical, we work with all the silicon vendors to bring real-time capabilities to our operating system kernel. That enables fast execution from silicon all the way to the applications. At the same time, there is the necessity to have virtualization platforms that make use of these advanced capabilities. So you have lots of new data features such as DPDK, SRAV, huge pages. All of these capabilities are needed at the microservices level. So your infrastructure, virtualization infrastructure, must also support these features so that you can deliver the data from all the way from silicon to operating system and now to the virtualization infrastructure, which will host the pods or virtual machines, whichever you are using, so that those applications can consume, can receive this data in an agile way, in a timely way. So that's really important, because if you bring the data center to the edge, but do not employ an infrastructure that can enable fast response, then you only do the half of the job. So you also have infrastructure, hardware, everything, full cloud, optimized in that sense.
Yeah, the synergy is extremely important, right?
Yeah.
Dr. Prasad, your viewpoint, please.
Maybe I'll reiterate the question. It's more on what infrastructure do we need for edge compute to succeed. Maybe in the context of Bosch, technologically we are already into the space of edge and 5G. We are developing capability, we are developing assets which could be building blocks from a technology standpoint. But what is missing in the ecosystem is what it would be worth enough to discuss. If you come from top, of course we have cloud centers, which again, let me reiterate, edge will never be able to replace cloud. So edge and cloud have to work together. From a top down, if I come, cloud centers are must. It has to have decentralization which means you cannot have a cloud center in Europe orchestrating data coming from India. So which means decentralization of cloud has to happen. Of course, we have Amazon, we have Azure's, they'll take care of it. The next layer is you have cellular towers today who are enabling 5G technology. Today, they are actually just transferring data. In the context of edge, they should also now enable necessary infrastructure to compute data going through them to the cloud, which means a heterogeneous compute environment where multiple parties in the ecosystem who are competitors will also be able to confidentially, trustably use that infrastructure. Second is cellular towers. Third, which is in the context of mobility, the expectation here for autonomous driving is every traffic signal in the world should be connected to each other, which means imagine I have 10 traffic signals in a geography. Are they connected to each other? Are they talking to each other? So this is the third layer. Fourth layer is, can the moving parts in the vehicle, for example, when you talk about vehicles on the road, there are more than 20 different companies who are taking their vehicles onto the road. It could be Mahindra, Tata, Kia, MG, BMW, Audi. Now, all of them have to trust this nearest edge center, which is traffic signals. So which means the data coming out of vehicle has to be published trustably to these traffic signals so that traffic signal load can be again distributed and certain infrastructure enablement can be done. The last layer is, as a vehicle, am I smart? Which means the data generated, can it be used? For example, to ensure that I either steer my steering or manage my braking, I doesn't have to take the data to traffic signal. Can I use the data in the vehicle itself? So first layer is, can the data developed in the vehicle be used? Second, if yes, if it's required to be doing more, to go to the next level, which is traffic signal. If yes, if you have multiple traffic signal, I have to manage a traffic signal of a large geography, then go beyond traffic signals to a cellular tower. And if cellular tower also needs to be bypassed, go to cloud. So at different layers, players have to come together to build this infrastructure so that a cohesive environment can be brought in to drive certain use cases to impact the society.
Yeah. That's quite an interesting example. I mean, today we have touched everything from sustainability, scalability to how to solve traffic jams also. I mean, that's phenomenal. So with that, we have some time to take some questions from the audience if there's anyone who wishes to ask any questions of this elite panel. Yes, please. Please do state your name.
Yeah, I am Brigadier Sanjay Rawal. I am a veteran from Indian Army. So the question to Dr. Guru Prasad, you said the data center will be there and we require the edge also. My question is, data center, the investment and other things which we have got and other things is based on a lot of power supply system, real estate and all that things coming up. It's a big investment coming up. And now we are having similar things want at isolated locations. He covered something about the strategy part of it and the security point of view. So my concern at a bigger thing is, so much of power will be required at various places. So are we going on to that, now we open up a new field by itself. That is one thing. From a data, to sustain all this, the energy will be required. So we're talking about green technology and everything. But a lot of investment in terms of data centers coming up, and now we are trying to go at the edge level.
So I think this is a very prominent question. People talk about sustainability and carbon footprint of edge compute.
Yes.
I think it is debatable. Today, I don't think any of us have answers because we have not done it. We are only visualizing what could happen in next 5 years. But if the architecture with which we are now driving, which means every traffic signal should have compute power, every cellular network should have compute power. It's humongous. If you look at India, just India, the power consumption in each of these infrastructure cannot be even imagined. So I think slowly we will get used to very simple demonstrators. For example, in Germany, we have demonstrated what is called as AVP, automated valet parking,
where a vehicle, you have a simple app in your phone, you just touch it, where the vehicle automatically navigates to a nearest and safest parking lot. So which means vehicle have to talk to an infra has to talk to a status of the parking, which is quite far, and the vehicle should navigate. So you have infra in each of these nodes which talks to each other, but at a scale, Mr. Singh was talking, we have really not demonstrated edge. So it's still an open question if you ask me.
There is a lot to foresee when it comes to 5G and its ability. Yes, please. The mic is right there, yes.
Hi, Kamath from Ericsson. I wanted to check on, we have, a cross spectrum of, operators, vendors, and PaaS and CAS, IaaS providers. So do you see in the edge, IPUs and DPUs being deployed more and more? You have offerings from AMD, Intel, NVIDIA. VMware has worked on integrating their stack onto some, but I'd like to know whether they're relevant for edge data centers and the use case you've talked about, whether IPU, DPU adoption is increasing.
So who would like to take a first stab at it? I think the operators would. Can you just kind of...
Oh, sorry. I was asking a specific question on IPUs like the Pensando chips, as well as NVIDIA Bluefield, or Intel has, your own offerings that are coming into the computes. So I wanted to understand whether from an edge standpoint, these sort of compute configurations are being leveraged or going to be leveraged anytime soon.
So I think, yeah.
So definitely, definitely what at AMD, you were asking about Pensando actually, this is an AMD group right now. We've got a data center business unit, and this data center unit, actually business unit, combines all of the silicon technologies effectively. CPUs with EPYC microprocessors, and then with GPUs, and then also DPUs, data processing units, and that's exactly the acquisition of Pensando. And we are working with the vendors, working with customers, really to create the total solutions. So Pensando is being deployed right now in data centers, and and you are getting a lot of benefits through that. Each of the functions obviously is contributing. With DPUs, we've got exactly the optimization of data path and passing in between the data centers and racks as such. So yes, this optimization is happening, and there is a holistic view that we take there.
Thank you. Thank you. And with that, we come to a close for this discussion. Thank you so much to the panel, and thank you to the audience for some questions. Thank you. Yeah, just give us a moment. We'll just give some momentum. Yeah.